Mexico Dust Symposium. Before we get started, to review a few housekeeping items. I want to just let you guys know that this is our first hybrid type of in-person event. So just it's a little we're gonna have a little I guess rough time here, but do appreciate your guys' patience with whatever kind of hiccups that we've run into to be able to have both hybrid virtual as well as in person. So we did run a little bit into some audio issues with our microphone up in the front, so we're just gonna go ahead and stick with the microphone onto the computer here so that we can have everybody be able to understand what's being said. And so this audio is available for your presentation through the computer or telephone. And so just look in the chat. There's some basic I guess you can say house rules if you want to go ahead and go through them. I won't read them all off, just to kind of give you guys an idea as far as how to be able to have a better experience both on the virtual as well as the in-person. And so I've told all my whole crowd over here in the in-person arena to behave themselves. You know what I mean? So we shouldn't be causing too much of a ruckus here to be able to have a good symposium today. And so yeah, the last time I can remember that we were out here in the I guess in person was in 2019 when I think it was the spring symposium. And so it's been I would say what 5 years since we've been out here in the New Mexico Farm and Ranch Museum. So it's a great pleasure and honor to be able to host and be a part of this Dust Symposium and be able to bring everybody together to share our hard work that we are doing in our own facets and how it all comes together in one kind of a big team type of deal. So as far as what we have today, our agenda consists of a full morning. I was wanting to potentially go into the afternoon, but we do have a good full morning of topics ranging from research, mitigation, dust forecasting, as well as some health effects. And so we have people from the New Mexico State University. We have folks from New Mexico Department of Transportation, the Environment Department. We're also able to have Albuquerque, their air quality program representative here as well. So it's good time to be able to talk about this as well during our peak windy season. Whenever we've had a lot of dust this year, it's been a very active season. So we've experienced that more so earlier this year than other years. With February, it seems like it really started picking up when we started getting a lot of that those cold fronts coming in, and with all the minimal precipitation that we've had. We've had some pretty exceptional drought conditions from last year. So this is pretty much a perfect storm, I would say, for dusty conditions and people becoming affected and impacted by the increased dust. And so it's not just limited down here to the southern part of the state, but it's also starting to have more impacts, more northern up in the northwest part of the state as well. So we're just it's great to be able to be here this morning and to be able to have our presenters present this morning. And so with that being said, I'm going to go ahead and kick off our next, or I say our first presenter. And it's from our local National Weather Service out of the El Paso area. Tim Bryce, he's with the National Weather Service out of El Paso. And so Tim, did you want to run your slides yourself, or did you want me to run them for you?
I like to run them myself.
Okay.
So
Okay.
Great. So thank you. So thank you, everyone. Thank you for having me. Sorry I couldn't be there in person. But my goal for the talk today is I want to try to set a groundwork on kind of the change in the climate that we've seen. Some of this will be very basic. Some of this you've seen before, but I want to set kind of a foundation for everyone. So then as we move forward in the rest of the conference and the symposium, we can kind of build from there. So let me Let me share my screen and hopefully all the technology works here. All right. You see climate change on the screen there, Mr. Armando?
Yes.
Very good. I love it when technology works. Well, first of all, I did want to get some definitions out of the way. I did want to talk about the difference between climate and weather. We hear a lot about it, both climate and weather on the news and things like that. They use very similar terms, but they are different things. I am, just so we're clear, I am a meteorologist, so I'm very involved in the weather side of things. I am not a climatologist, but climatology and meteorology, they cross over. They have a lot of common theme. So I know I can speak openly and freely about climatology. So weather is basically just in it's short-term changes in the atmosphere. And when we're talking about short-term, we're talking about minutes to days. It usually involves a specific time or a specific place. I tell people if you're looking out the window, you're looking at weather versus climatology. Climatology is expressed in like terms like average temperature, average precipitation. It usually changes very slowly. It's usually regional or long term. So we have a saying in the Weather Service, climate is what you expect, but weather is what you get. I use the example of, if you invite somebody to Las Cruces to come visit you during the summer and they live up in, let's say, New York, and they ask you, what's the weather going to be in Las Cruces this summer? When I come visit you, you say, it's going to be hot. It's going to be, just lots of sun. So they land. You go and pick them up at the airport. But the day you pick them up, it's one of those days where you have some clouds, it's a little cooler, maybe some rain, and they get off the plane and they're like, I thought you said it's hot and sunny here and it's nice, kind of cool and cloudy. He said, yeah, usually it's hot and sunny. That's the climate. But today it happens to be kind of cool and cloudy, and that's the weather. So that's the difference between the two. Climate is what you expect, and weather is what you get. And when you look at that, here are the climate normals for Las Cruces. And it's kind of this nice, smooth curve. Again, because when you're talking about climate, you're talking about an average. So it's basically what we do to get the climate. You see, it's the monthly climate normals. So you take 30 years. So if we take the temperature on June 1st and every June 1st for the last 30 years, add them together and divide by 30, that's that average temperature that you would see on June 1st. Uh, are there years where it's warmer than that or cooler than that? Yes, but that's the average. When you want to look at the actual, so this is the average climate for Las Cruces for the last 30 years, but here's the actual numbers. This is from 2023. I pulled this up. This all of last year. So the top of the red line would be record high temperatures. The bottom blue line there would be record low temperatures. And this brown kind of ribbon across here is what your average temperature is. And then these blue lines that jig-jag up and down are what the actual temperatures were for each day last year. So again, you can see how that blue ribbon kind of is nice and smooth, kind of like we saw on the other screen. That's climate. But you can see on a daily basis how the temperatures varied. Days were warm, days were cold. So you can actually, and I was looking at this kind of closely. If you look closely, there's a lot of days where we're bumping up against the record highs there in July and August, there in early September, and even again in November. I don't see anything that was close to any of the record lows. So that was kind of one interesting thing. But we all know that last year was a very hot year, and all signs are pointing again to another hot year, which could mean another dry year for us. So that's just basically the difference. Climate is kind of that running average, whereas weather is that daily ups and downs in the temperatures. How do we measure a changing climate in our world? There's lots of different ways that we can, from ice cores to tree rings. We have climate models. There's certain things, looking satellites is a great way because it's up in space, it's taking a picture, it's very consistent, but we've only had satellites up there doing that for like 10, 15 years. So it's to get these, understand the climate change, to understand the climate trends, we need a large data set. We need to be able to look back dozens, hundreds, or even thousands of years to get a good idea of what is the climate doing. So with satellites, it's a start. Surface observation systems, again, those are a start. But looking at those ice cores and the tree rings, we can go much further back and kind of infer things from those. And then we have climate models, just like there are weather models helping us forecast the weather. There are climate models that forecast the weather 1 month, 2 months, 3 months, 6 months out. And then those also, we have climate models that they can run out years ahead of time. So those are all just different things to help us understand what's happened in the past and then what is going to happen in the future. So what is causing climate change? I tell people when I talk to kids in school, to a certain point, greenhouse gases are a good thing. Life on Earth would not be able to exist without some of these gases in our atmosphere. They act like a blanket. They allow they allow the sunlight in, and then they allow some of it to escape. But they also trap some of that temperature, that heat energy in the atmosphere. Life on Earth as we know it would not be possible if we did not have these greenhouse gases, carbon dioxide, water vapor, nitrous oxide, and the other chlorofluorocarbons. The problem that we're seeing is that we are adding too many of these greenhouse gases. I use the example of, when it's cold at night, you put a blanket on you and you feel nice and comfortable. But what's happening on the Earth is that we've got one blanket on there, and then someone's coming in while you're trying to sleep, and they're putting another blanket on, and then someone else comes in, and they're putting another blanket on. We keep piling the blankets on, and eventually you're under all these blankets. You're going, it is getting uncomfortably warm under all these blankets, kind of thing. So the same thing is happening on the Earth. We keep adding these greenhouse gases, and the greenhouse gases are just doing what they're designed to do. They're trapping some of that heat, but the more that we add these gases into the atmosphere, the more heat that they're tracking. So all these greenhouse gases, whether it's nitrous oxide, carbon dioxide, methane, are all showing very significant upward trends. The chlorofluorocarbons either are flat or maybe even descending a little. So we're doing better with those. But the other ones, and especially carbon dioxide, is really showing just this continued upward climb. And it's carbon dioxide that is actually giving us the biggest kind of boost in our atmosphere as far as the heat that is being added. So the carbon dioxide is really contributing to the most. Over the years, carbon dioxide does fluctuate in the atmosphere. It does go up and down. I'll show you another screen here in just a second about what causes the fluctuations in this. But you'll see it's usually been running in this nice narrow 250, 275, between 175 and 275 parts per million over the last several thousands and thousands of years. But it's not until recently where we've kind of flipped off the chart. We were running 280 parts per million, maybe up to 300, but now we're 25% more than that. We're up at 419, and really, like you saw in that other slide, just no sign of it even slowing down. So we're way off the charts of where we've been in the last thousands and thousands of years. So that is going to definitely, since this is just a gas in the atmosphere, it's one of its jobs is just to lock in heat. We're beginning to see signs of that. What increases carbon dioxide in the atmosphere? Outgassing from the ocean, decomposition of vegetation, venting of volcanoes. I just saw there's a volcano going that we had some nice satellite images of as it was venting sulfur dioxide and other gases up. Wildfires, even animals, sheep, cows, can add carbon dioxide, methane to the atmosphere. These are all natural things. Some of the things in the atmosphere that help decrease carbon dioxide is photosynthesis. All the trees, all of the plankton in the ocean, they're all taking in carbon dioxide, and then for the plants, they're kicking out oxygen. So there's a nice cycle. So we usually keep a balance between what increases and what decreases. we're keeping a balance. Unfortunately, there at the bottom of this list here, we see human activity, deforestation, and burning of fossil fuels. Those are kind of beginning, we're seeing that that's throwing that balance off. We're putting in too much or more carbon dioxide than we can take naturally out of the system. And we're beginning to see some of those impacts. And there are some pretty clear signs that it is human caused as far as the amount of carbon dioxide in the atmosphere. Like I said, carbon dioxide used to run at a nice steady amount. But once the industrial age started going in the late 1800s, early 1900s, it started to tick higher. And then as we started to have emissions more and more, so this is the gray line is the annual emissions of carbon dioxide, and the blue line is the amount of detected carbon dioxide in the atmosphere. And you see, as we've been increasing emissions, the amount of carbon dioxide detected in the atmosphere continues to climb, and now they're almost in lockstep. So there's a pretty clear signal that as we are emitting more carbon dioxide in the atmosphere, more carbon dioxide is building up in our atmosphere. And again, carbon dioxide's just doing what it normally does, and that is trapping some of that heat. So the more of it there is, the warmer we're going to see the atmosphere. So when I talk to kids, one of the challenges with climate change and talking about this is that, like I said, when you look out the window, you're looking at weather, but it's very hard to look out the window and see climate change. It's very hard to picture it, but this is one good example, and this is a glacier that was in one of the fjords up in, I'm not sure if it's Norway or wherever it is, but you can see how back in the 40s, this whole valley was filled in with ice. And now, 60 years later or so, when this picture was taken again, how that glaciers are treated way back up into the mountains. You've got a large body of water here. Now all that ice is gone. It's all melted away. So, here's a good example of you can see actually climate change in action. But, we've got this idea of carbon dioxide, methane being in the atmosphere. It's going to lock in more of the heat. So we've got an idea that we should be seeing things. When you're sick, you take your temperature. Your temperature, when you're running a temperature, it doesn't tell you exactly what's causing your illness. Is it the flu? Is it COVID? Is it something else? You just know that you're sick. So that temperature is just a kind of a simple um, sign that you're not that you're sick. Well, we can do the same thing with the Earth. We can start to see, do we see signs of a warming world? If we were, we would expect to see air temperatures over the land would be increasing, air temperatures over the ocean increasing, sea surface temperatures would be increasing. We would see Arctic sea ice decreasing, and all of these things that we are definitely seeing. I showed you the example of the glaciers. Global sea level rises also coming up. These are all just symptoms that we are seeing a warming planet. Look at some of the numbers. I updated my numbers, and for some reason, on all my graphs that I updated, they changed the font for the years. So I apologize. I'll read off the years across the bottom. But basically, this shows the increase in global temperatures starting in 1880 and goes to just a little past 2020. And you can see a definite trend, warmer in the last, 40 years. Speaking of that, it's been actually 47 years since the Earth has actually had a colder than average year. Every year for the last 47 years, we've been at some point either a little or a lot above average. And as this is saying, 2023 was the warmest year on record. And it was, even for us here in New Mexico, it was definitely a very, very, very warm year. So again, these are all just symptoms. The average temperature trend in New Mexico, definitely back from 1895, you can see a steady increase. Again, it's important when you're looking at graph like this to just check your scale. Over the last over 100 years, 120 years, we've seen an increase in temperature of 2.5 degrees. But then when you start to multiply that out, and also factoring in the fact that we're continuing to add carbon dioxide to the atmosphere, methane to the atmosphere, you would expect that this trend to at least continue and if not accelerate a little. We're seeing the heat content of the oceans. I put this slide in here because I was reading a study recently that talked about how if the Atlantic Ocean continues to get warmer, it actually affects the circulation for our monsoon season. I've got a graphic here in a few minutes of that. So, you know, as we're pretty far from the oceans, but we can see impacts from it. El Nino and La Nina in the Pacific Ocean have impacts for us. But this particular study did talk about how as the oceans get warmer, it changes the circulation patterns, which could then impact us as far as, do we get more rain for our monsoon season? Do we get less rain? And this study was implying that we would see less rain for our monsoon season. It kind of shifts the moisture flow that we need to get during our monsoon season. Some other symptoms of a warming planet: less snow cover during the springtime. This runs from 1970, this graphic on the left, to a little past 2020, 2023, I think. Glacier mass is also going down. Again, same thing, 1970 to 2023. So you can see a definite decrease in the amount of ice and glaciers, definite decrease in the amount of snowpack that we can hold on to. And again, those are all just symptoms. Sea level rising, slowly coming up. One of the things when I started looking into this, I never thought about, you always understand the concept that if you melt a bunch of ice and dump it into the water, the sea level is going to rise. But whenever you heat something up, it tends to expand and get bigger. So all by itself, if we just heated the oceans a little bit, the sea levels would have to come up just from the fact of thermal expansion. So you got thermal expansion, melting of seawater. So all of these things going together are kind of compounding each other, and we are seeing sea level rises around the world. So what does the future look like? We've all heard this, that if we don't do anything, projected global temperatures will continue to not only rise but increase. If we slow things down, we've set the ball in motion. It will take some time to kind of slow it down. If we were like to cut things off, even then we would still have some increase before a flat line. So, we've got to find that middle ground of where we can start to adjust things and slow the amount of emissions that we're putting into the atmosphere, and then we can slow this warming trend that we've been seeing. Same thing on the sea level rises. If we don't do anything, we're going to continue to see higher sea levels, which can impact a whole slew of things along the coast. Lots of communities built along the coast. Lots of people live now within just a few miles of the coast. This could have direct impacts on them. Other impacts of climate change that we're seeing, increased extreme weather. We're seeing in parts of the Midwest heavier rain events, more variability in our winter weather. Agriculture, in some places you're going to be able to grow crops longer, but other places it's going to become inhospitable to grow crops. And pests, the longer you're warm, they got more time to have pests chewing away on your crops. So that's a problem. And heat stress on animals and people, specifically for, I talked about this as we get warmer. This is a paper that I came across recently that talks about how we need to have, we have the ridge that pulls in our monsoon moisture from the Gulf of Mexico, from the Gulf of California. And they're talking about as things get warmer in the Caribbean, that actually shifts this ridge off to the north and to the west. And actually, in this case, where you see red on this bottom graphic here, that's a drying trend that they're anticipating as a potential. So as the earth is getting warmer, we could see the monsoon season shift and change. So that's, one example of a potential impact, and we're not getting our monsoon rains, then what's not going to happen is that we're not going to be able to grow vegetation, so that when we get back around, through winter and into spring, that vegetation will hold the ground, a little better. If we don't have that vegetation there, then when the winds do come in the spring, we're going to see more dust events. So if we're not getting that monsoon moisture to grow the plants, it's going to lead to more dust problems in the subsequent years. So that is one of the potential impacts. One of the things that we've specifically seen, and this is just we haven't done a formal study on this. This is just anecdotally what we were doing. We have a new product that we started issuing back in 2018. It's called the dust storm warning. We've, for many, many years, we've always issued kind of what we call dust advisories and things like this. But this is something that we specifically issue now that is for very impactful, short fused, very geographically centered dust problems. So we started issuing those in 2018, and you can see, of course, we get many of them during the actually monsoon season with the haboobs and the dust storms that we get associated with thunderstorms, but we do get them in the springtime. But what we've noticed recently, and this chart kind of shows it in 2022 and 2023, and even this year, Armando kind of hinted at it, was that we're seeing more dust impacts earlier in the year. And I don't know, like I said, we haven't done a formal study on this, but it is something of interest to note that we are seeing earlier winds systems coming across, systems that give us dust, and more dust impacts earlier in the year than we have just in the last few years. So it'll be interesting to see, when it comes to climate, you can't look at just a few years, but you have to look at several years, like I said, and it's an average. But this is a trend that we have noticed recently. So that was one thing that we did find interesting. So these are just some of the impacts that we're seeing on the Earth, some of the possible impacts that we could see in southern New Mexico, Arizona, as far as the dust goes. There are lots of tools. If you are interested in this, want to do your own research, there's lots of online resources. One of the ones I got a lot of my graphics from for this presentation is one called climate.gov. It's part of the parent organization of NOAA that I work for, but they have lots of cool graphs, lots of good information there. You can see trends and things. Another one, Climate at a Glance, has a lot of neat resources. You can do that one graphic where I showed the trend of temperatures in New Mexico. You can do that for any state, any location, and it'll show you that trend and and you can set the time frame for how long you're kind of interested in. So that's a good site to use. Just again to visualize. Again, the challenge with climate change is helping people visualize it and see it. And one of the best ways to do that is with a nice chart. Climate monitoring, the National Climatic Data Center or the National Center for Environmental Monitoring has this climate monitoring dashboard you can use and look at. So that's a good resource. And I think that's it. So I really appreciate you guys taking the time to have me come. Like I said, I know we're all kind of familiar with this, but I wanted to kind of set the foundation and say that we are seeing changes to our climate, and that is definitely going to have impacts for us as far as heat, as far as moisture and rain, and as far as dust goes. So I did kind of want to set that foundation. Now as you guys go forward, we can kind of have that discussion with that in the background. So again, thank you all, and I don't know if we got a time for a question or two if someone would like to.
Thank you for the presentation, Tim. That was very interesting, and that dust product is interesting as well as far as I guess the prediction of when a storm is going to happen.
Yes.
And so let's see. I was going to kind of want to know if anybody has any questions or for Tim on the online platform, or maybe even in person.
I've been forecasting here in El Paso for 30 years, and what I've liked in the last few years is that we're getting, dust is one of our big things, but it's not until recently that we've started to get tools to help us forecast dust. When we used to, 20 years ago, we could see the storm system coming. Oh, it's going to be windy. Well, that probably means it's going to be dusty. Well, what I like now is that we have 2 or 3 models that actually specifically help us see plumes. It forecasts plumes of dust. And so those are just tools that now we're able to use to help us forecast with a wind speed of this, with a wind direction of that, where do these plumes going to go? Because a lot of these plumes all start in certain dust source regions across New Mexico, Arizona, and in northern Mexico. And depending on which direction the wind is blowing, if it's a west wind, the dust plume is going to go west to east. If it's a southwest wind, which we get a lot in the spring, that southwest flow, it's going to pull all those dust source regions down there in northern Mexico and brings it up into southern New Mexico. So I've really liked that we now have several models that we can use to help us, at least go more than just, well, it's going to be windy, so yeah, it's going to be dusty. Now we can start to see, dust concentrations, timing on the dust. So that all helps us better get the word out. Instead of waiting to see, oh, here comes this big haboob, this big dust cloud, we can start issuing these dust products even ahead of time to give people, time to get off the road, get their windows closed, whatever they need to do to protect themselves from these dust plumes as they're moving up. Now we're able to give them more of a heads up that they're coming. So that's what some of these products are. That's why we've added new products, because we have these new capabilities.
Yeah, and so like for example, this past Saturday, we had a pretty dusty day. However, I mean, up here in the little bit northern part of the county, here in Las Cruces, with our dust, I guess you can see our PM10 monitors, we didn't
Mm-hmm.
have any exceedances, and unlike the previous dust event that we had, where more than half of our, I guess you can say more than our monitors were had an exceedance, and so it's interesting though how like just that little bit of variation in the trough axis on the lee
Mm-hmm.
side of it, if it's a little bit more south,
Mm-hmm.
it'll start pushing all those pollutants more south, east into like the Big Bend area versus,
Right.
I mean, more into the panhandle of Texas and Oklahoma.
And I like, the other tool that we use a lot is we have satellites now. And, it used to be in the old days, again, 20 years ago, you had visible, you had infrared. But now we have, dozens of channels, and we can combine these channels so we can actually pull out just by combining these different channels in the satellite as it looks down. We can actually, kind of narrow in on just the dust. I was doing an example the other day where down in northern Mexico they had three fires, and we had a dust source region, and you saw these four plumes coming off, and I was flipping back and forth between the fire detection satellite products, and you couldn't see any of the dust, but you could see all the smoke and the heat from these three fires. And then I flipped back over to the satellite in our dust detection, and then the smoke and the heat from the fires disappeared, and all you could see was this plume of dust. So we are getting more and more tools to help us detect and anticipate this dust. What I'm looking forward to is seeing what different people here, different research help us better understand, what causes, how what helps that dust get lofted higher into the atmosphere, what wind speeds do we need to get dust moving, and things like that, in addition to the impact. So that's what, I'm looking forward to, and I'm hoping that we can all continue to work together, better understand where we're getting dust, how it gets in the atmosphere, and then how it impacts people.
Yeah, these dust products are just getting that much more compelling as far as I mean showing the impacts, and so I personally enjoy using the Deborah dust product from NOAA. It really brings out the those
Hmm.
dust plumes. Anybody else have any other questions or want to have any comments for Tim? That was a great presentation. Thank you, Tim.
No problem. You guys have a great day.
Thank you. You as well. We're going to go ahead and go on to our next presentation. And so we're going to have Saraj Dithal from New Mexico State University. He'll be talking about the meteorological analysis and numerical simulation of Southwest dust episodes. One moment while I get up the presentation. Yeah, yeah. So talking into the computer here. Yes, the question one. Yeah, we can use the space bar too.
Good morning, everyone. Just to make it confirm, can everyone hear me in the online?
It sounds good, but you're in preview mode. It's showing your next slide instead of the full screen. That's good.
Good morning, everyone. Today I'm going to talk about the synoptic analysis and numerical simulation of Southwest dust events. This is a product of our ongoing project called the Dust and Snow Project, funded by the NASA, and we have a big team of the collaborators across the different agencies, the universities, and the federal agencies. The background animation here shows the last Thursday dust plume evolution that occurred over the North Chihuahua Desert. So I'm going to talk about more on the forecasting side and how we could get some meteorological precursors to understand the formation and the location of the dust storm. This is the outline of my presentation. I will start with talking about why we should care about the dust event, and then I'll talk about the type of the dust events in the Southwest US. And then I'll briefly talk about the ways to mitigate the immediate adverse impact of dust event, focusing on the early warning system. And then I'll present some of our analysis related with the two spring season dust storm analysis. We mostly focus our analysis on the meteorological precursors and some of the modeling efforts. So beginning with the why we should care dust event in the Southwest, especially the most important and the immediate adverse impact from the dust event is on the air quality and the human health. As we can see on the left side of the slide, we have a strong dust event hit in the last process. So obviously it's going to degrade the air quality and impacts the human health. The next immediate impact we can see in the transportation, that may be road transportation or the aviation transportation. So the figure on the top right, we can see the I-10 crash, the crash over the I-10 because of one of the dust event. And the bottom figure on the right-hand side shows the delay in flight over the Phoenix airport because of the dust event. That's why we need to track what's going on, what happens when the dust event forms over the region. Besides that, there are a lot of impact of the dust, but as of now, we are just focusing on the immediate impact of the dust event for this presentation. So looking at the different meteorological disturbance, and based on the Lee and Wang 2014 studies, there are 4 types of the meteorological disturbance that can create the dust event in the Southwest US. So the dust event can be formed with the frontal activities, it can be formed with the cyclogenesis activities, and it can be formed with some meso and small scale disturbances. So there are basically 4 types of the dust event in the Southwest. But generally speaking, there are two major types of the dust event. One is the synoptically forcing, and another one is the convectively forcing dust events. So if we see the figure on the left-hand side, that is the ghost satellite image, where we can see the dust plume indicated by the magenta color, which occurred last Thursday on April 25th. So this is a type of synoptically forcing dust event. On the right-hand side, we can see the big dust wall, which is because of the convective forcing. This is the example of one haboob that formed over the Phoenix region and impacted the whole metropolitan area in that region. So we want to here focus on the synoptically driven dust event. This type of the dust event generally forms in the spring season, that is in the northern hemisphere, between March and May. And these type of the dust events are relatively long-lived dust event compared with the convective dust event, and it can transport a lot of dust from the source region farther apart from the source region. Now the question comes, what are the ways we can mitigate the impact of the dust event? So the first thing is early warning system. If we have a capacity to forecast or provide the early warning system of the high wind and the blowing dust event, then we can definitely reduce the immediate impact of the dust event occurring in that region. So this can be achieved with the good weather forecasting and air quality forecasting stuff. Beside that one, I like to point here is that if we have a better understanding on the meteorological precursors, that can provide some information on the location and the intensity of the high wind and the possible dust event formation. So if we know and if we have a good understanding on the meteorological precursor, then we can also provide the early warning system for the possible occurrence of the dust event. So additionally, if we have a better model, then we can achieve the good early warning system to reduce the impact of the dust events. So in order to understand the synoptic precursor and other some meteorological precursor and the modeling effort to reduce the immediate impact of the dust event, we try to analyze the two synoptically forced spring season dust event over the southwest. For our analysis, we took the 2013 April 16 dust event. During that event, dust plume was formed over the southwestern Colorado Plateau, and the resultant dust plume was transported in northeast direction, where a lot of dust was deposited in the San Juan Mountain, and that created a strong dust and snow event during that event. In the 2017 case, big dust plume was originated over the northern Chihuahua Desert and impacted the whole the metropolitan area. And the dust plume subsequently traveled in northeast direction, and it impacted over the Lubbock region as well. These two regions are the most predominant dust source region, and a lot of dust emitted from this region for the past couple of decades. That's why we chose these two case studies to understand what's going on the meteorological side of before the formation of the dust event. So obviously, the research goal of this project was to understand the common large-scale meteorological precursor. Here, we want to focus on the polar jet and subtropical jet interaction. In the second part, we want to test the weather model, whether it can better simulate the dust episodes or not. For this, we use the different type of the data sets. For large scale meteorological precursor analysis, we use the ERA5 reanalysis data set. We mostly focus on the analysis of the upper level, mid level, and low level wind. Also, we looked at the geopotential height and the mean sea level pressure system. For the numerical simulation, we use the WRF-Chem model. For the dust emission side, we use the F1 dust emission scheme. The base version of the F1 dust emission scheme does not include the drag partition. That's why we use the recently developed Modis always-based drag partition approach to insert drag partition inside the FY dust emission scheme. And this model was developed by the Chappell and Webb 2016. I would like to begin with how the jet stream and the surface weather and wind are related. So depending upon the structure and the intensity of the upper level wind pattern, which is generally described by the jet stream, we can figure out what could be the possible impact at the ground level. So if we have a nice, if we have information on the upper level divergence by looking at the jet stream, then we can assume what would be the impact at the ground level. So the formation and the structure of the jet stream is always important to understand the weather at the ground level. Now the question comes, what happens when the jet stream interact with each other? So over the western part of the US, we generally have the polar jet stream situated around 60 degrees north, and then subtropical jet stream situated around 30 degrees north. In the spring season, these two jet streams are prominent in that region. So what happens when these jet streams interact with each other? So how this will modify the upper level divergence and how that creates the strong pressure gradient at the surface level, which ultimately dictates the strong wind capable of emitting dust in the source region. That's what I will be focusing my talk on the meteorological side. So this slide shows the evolution of the 250 hectopascal wind and geopotential high. The red color here indicates high wind and the blue color indicates the low wind. So this 250 hectopascal wind pattern shows the evolution of the polar jet and subtropical jet. Here I have shown the evolution of the polar jet and subtropical jet from 18 UTC on April 15 up to the 18 UTC on April 16. So around 18 UTC on April 15, we can see the polar jet and subtropical jet are apart, and as time progresses, what happens, this polar jet and subtropical jet started to come together. Around 15 UTC on the April 16, we can see they actually interact with each other, and this is the time when the dust storm actually started to form over the southwestern part of the Colorado Plateau. Now, I would like to show what was the mid-level flow and the low-level flow when the jet interaction was occurred. The figure on the left panel shows the evolution of the polar jet and subtropical jet. The middle panel shows the evolution of the wind and geopotential height at 700 hectopascal, and the figure on the right-hand side shows the evolution of the 10-meter wind and mean sea level pressure. So what we can see around 18 UTC on the April 16, when the polar jet and subtropical jet interaction occurred, that created the strong pressure gradient at the low level, which we can see the strong pressure gradient over the Four Corner region, and that pressure gradient was able to form the strong southwesterly flow. And once the dust was emitted from the source region, the mid-level strong southwesterly flow was able to transport that dust plume out of the source region and ultimately deposited those dust into the San Juan mountain range. So this slide is to show when we have a strong pressure gradient resulted in a strong southwesterly flow, and that is the time when we have the strong dust plume formed over the southwestern part of the Colorado Plateau and transported over the Snow Mountain region in the San Juan Mountains. In the 2017 case, we also looked at the evolution of the 200 hectopascal wind, 700 hectopascal wind, and 10-meter wind system to see what's going on the upper level, mid-level, and low-level wind. So around 18 UTC on March 22, we can see the polar jet and subtropical jet, they started to interact with each other. And around 18 UTC on March 23, we can see those polar jet and subtropical jet actually merge together. Once they merge, we can see the strong pressure gradient formed over the northern Chihuahua Desert region, and that resulted in a strong southwesterly flow. And once the dust was emitted, the mid-level flow around 700 millibar was able to transport dust out of that the northern Chihuahua desert region. So we can see here, once we have the strong pressure gradient at the low level, strong southwesterly flow was formed in that region that emitted dust over the northern Chihuahua desert. So to summarize the first part of our analysis, what we have seen here is the common upper level precursor. We found the polar jet and subtropical jet interaction. And of course, we need to look at is the similar type of the interaction. We can see in a different cases. This will be our next task in the future. Then I tried to look at what happened during the last tested dust event. So was there polar jet and subtropical interaction during that event? And then we found yes. So the figure on the left hand side shows the evolution of the dust plume on April 25th around 2051 UTC. And when we looked at the RAP analysis, we found that polar jet and subtropical jet interacted just over the northern Chihuahua desert, and we can see the strong southwesterly 700 millibar wind was formed in that region, and that was able to transport a lot of dust out of the northern Chihuahua desert. So we have a pretty good signal that polar jet and subtropical jet interaction might be a key indicator to predict where and the intensity of the dust event in those regions. Moving into the second part, we try to understand the ability of the WRF-K model, whether it can simulate these dust events effectively or not. So for this, we use the WRF-K model. The simulation domain consists of the 3 nested domains having the resolution of 18.6 and 2 kilometer. We initialize the model with the ERA5 reanalysis data. On the dust emission side, we use the FWA dust emission scheme. As I mentioned earlier, the base version of the FWA dust emission scheme does not include the drag partition. So we introduced the drag partition from the Sapel Webb 2016 model, that is Modis Alberto based drag partition. So these are the simulation domain for the 2013 April 16 case. The 2 kilometer domain covers the most of the Four Corners region and its peripheral region. In the 2017 case, the 2 kilometer simulation domain covered the northern Chihuahua desert and its peripheral region. Then we try to analyze the different simulated fields to look at how these fields are correlated with the evolution of the dust plume in the satellite imagery and in different observational data set. So the left panel shows the evolution of the dust plume from the MODIS satellite, and the right panel shows the WRF-K simulated dust emission flux for 2013 and 2017 case. In the case of 2013, we can see around 16 UTC on April 16. The high dust emission flux was occurred just over the southwest Colorado Plateau. And if we see the satellite imagery, and this is the exact region where the satellite picked the evolution of the dust plume. In the 2017 case, around 18 UTC on March 23, we can see high dust emitting flux over the northern Chihuahua desert. Then this is when we looked at the MODIS satellite imagery, we can see these are the regions where the initially dust was picked for that event. Then we also try to look at the evolution of the dust in the atmosphere. So to track the evolution of the dust in the atmosphere, we looked at the aerosol optical depth from MODIS and from the WRF-K simulation. The left panel shows the evolution of the AOD from the MODIS, and the right panel shows the evolution of the dust AOD from the WRF-K model. So looking at the upper panel, we can see our model was capable to replicate the evolution of the 2 dust plume, one over the southwestern Colorado Plateau and one over the Farmington region, consistent with the evolution of the dust plume that we see in the satellite imagery. In the case of 2017, our model was able to capture the evolution of the AOD consistent with the evolution of the AOD that we have seen in the satellite imagery. Then we also try to look at the evolution of the PM10, and unfortunately, we did not find the PM10 station for the 2013 case because we were interested to look at the evolution of the PM10 in the dust transport transect. However, we have found a couple of stations to look at the PM10 evolution. So we took the 2 stations from the New Mexico. One is the West Mesa station and another is the Anthony station. We looked at the evolution of the PM10 in those stations. When we looked at the simulated and observed dust plume, we can see the close correspondence between the simulated and the observed dust plume, which we can see here in the slide, which is indicated by the oval, the red oval region. So once we have once the dust storm started around 18 UTC, we can see the spike in the PM10 over the West Mesa station and the Anthony station. So looking at these analysis, we summarized that the WRF-Chem model with the modest albedo-based track partition in FWA can simulate dust event at different geographic locations. Now I want to move into the conclusion section of our work. So based on our analysis, we conclude that polar jet and subtropical jet interaction can provide a valuable information for the possible formation of the dust event. So we can treat that as an upper level precursor for the dust event formation over the southwest region. And from the second part of our analysis, what we can conclude here that WRF-Chem with the albedo-based track partition in FWA model can simulate dust events at different geographic locations. So now the question comes, what will be the possible implication of our analysis? And of course, the aim here is to provide the early warning system. So our analysis could be used for the forecasting an early warning system. And next one is to understand the dust cycles studies, for example, dust and stone, dust aerosol interaction, and so on. So with this, I would like to thank our funding agency, NASA. Most of our simulation we did inside the USGS SciNet. So we would like to thank the USDA for providing the computational resources. And finally, I would like to thank the New Mexico Environmental Department for giving me the opportunity to present our work. Thank you so much. And if you have any question, I would be more than happy to answer them. Did that work?
Yeah. Does anybody have any questions for Saraj? Either in person or online? That was a great presentation, Saraj. Thank you for sharing that your work with us today. And so just did have a, I guess, I was interested in, lucky for me, I get to be able to see some of these presentations beforehand, so I get to be able to get a little preview and just get an idea as far as, I mean, just, the work that you're doing with the simulated for these exceedances. So I was just pretty, I guess you can say, taken back how accurate they are, close to the, I guess, pretty close to the hour, of course, whenever they're having the peak PM10 exceedance. So you know, that, I mean, I don't know how far like you're wanting to go forward with more so with this, but maybe that would probably be a good tool for us to be able to utilize in the future to help us with some of our like our early warning or like our health alerts, just to kind of get an idea what the model is showing, and then I guess over time to maybe kind of be able to gauge how accurate it is. Have you done any more dates or expanded more than some of these other events?
So thank you, Armando, for the question. So the next goal of our project is to analyze do more case studies and to investigate how our model can replicate or can better forecast the evolution of the PM10, and that will be our next goal. But what we have seen from these two case studies and another one, summertime case studies, focus over the Phoenix season, that our colleague did most of the work. So we found that the algorithm model, when we imposed in the alpha dust emission scheme, is obviously shows the improvement over the base version of the dust emission scheme. So, but we need to test multiple case studies to make sure how much in terms of the quantitative analysis this kind of brings the improvement for the air quality model or the forecasting stuff.
Great, thank you. Very interesting. And just did want to kind of point out that that event date over there in the Four Corners area. And so, I mean, just we do have a monitor up there in the San Juan County, and we just barely got I guess you can say installed in 2017, in the end of 2017. So our monitors did pick up that event, or I think it was in 2013 that you guys had
Yes.
done that case. So I was kind of wanting to kind of see if we had any kind of information regarding that on our monitors. And so, well, it was very interesting. Thank you.
Yeah, hopefully you guys will see a more research focus over the Southwest region in future. We are planning to bring a lot of analysis related with the early warning system and dust transport pathways, etc., etc.
Great, thank you. Appreciate your presentation today. All right, so that completes our last presentation, and we'll go on to our next one. And it'll be with Bill Hutchinson, as well as Trent Bodkin with the New Mexico Department of Transportation. And they'll be talking about the Lordsburg Playa Dust Mitigation Project update.
Great, thank you. Can you see my presentation?
Yes.
Great, thank you. My name is Trent Bodkin. I am the Bureau Chief of the Environmental Bureau here at the Department of Transportation in Santa Fe. I'll be presenting today with Bill Hutchinson. He's the section manager for the roadside and community design section, and we are the co-managers of the DOT dust mitigation project. So today we'll be presenting on the Lordsburg Playa watershed restoration to reduce the severity of dust storms on I-10. Little background on Lordsburg Playa. The Lordsburg Playa is a mineral soil flats wetland located in a former perennial Pleistocene lake bed from the Wisconsin glacial period. It is seasonally inundated in summer and winter dependent on precipitation runoff. The wetlands there are highly degraded due to surface erosion, demonstrated by pedestal plants, and deposition, demonstrated by buried plants. It's also an important pathway for migratory waterfowl. You can see its location in the state is in the southwestern corner of the state along I-10 near the Arizona state line. A little background on the Lordsburg dust storms, and then we'll get into our actions. From 1965 to present, there have been over 40 dust visibility related highway deaths within this approximately 15-mile area of Interstate 10. From 2012 to present, there have been 21 deaths, 43 closures of I-10, and 121 dust events requiring Department of Public Safety and DOT response to maintain safety within this area. Here's a graph showing the frequency and hotspots of dust-related crashes per mile post. You can see the hotspot there is located at mile 12. That is, due to the prevailing west-northwester winds within the area that push the loose sediment across the playa and across the interstate there. There's also mile post 7, the red dot. That is actually as a result of southerly winds that push up from the small playa we call the Road Forks Playa, which is dammed up against the interstate. So today what we're going to be talking about is what we call phase 3, which is the greater Lordsburg Playa. This is looking at the entire 16 plus square miles of playa floor within Lordsburg Playa, 35 square miles of watershed. It's primarily demonstrated by an eroding playa surface, so that's the flat playa surface itself, and then the eroding western watershed, which within that red box there would be on the western side of that area. Land is primarily managed by the Bureau of Land Management and the State Land Office with some small private in-holdings. So this is what the Lordsburg Playa looks like whenever it has water in it. You can see the pedestaled plants there in the foreground. You can see the snowy caps of the Gila in the far right there. This is another common view you'll see driving across I-10 of the Palencia Mountains mirrored against the inundated Playa lake surface. But this is what it looks like most of the time. And this is more of the environment that we have, which is generating dust events whenever you have a dried out playa surface, which is covered by a fractured crust. So as we began to analyze this, we started this project back in 2014. Here's a little background on it. In 1993, the BLM Resource Management Plan identified playa shoreline as fragile soils with poor grasses and all grazing allotments in unsatisfactory conditions. So those are the slashed purple polygons and the slashed green polygons within this. You see there on the western shoreline. In 1998, the entire playa surface was declared an off-highway vehicle closure area due to recreational vehicles, which were actually sail carts. They were causing dust plumes responsible for 4 fatalities within a July weekend period. And that remains closed to this day through a temporary closure. You see that also overlaps with the western watershed area there. 2018 NRCS soil survey, which is the orange background polygons there, showed, this is pretty simplified, but the highly erodible soils within that. You see that they all overlap within the western watershed and the western playa surface area, which we pretty quickly identified as being the culprit for being the area where it's contributing excessive amounts of sediment. So in 2020, we conducted a surface disturbance analysis using our own team and consultant team to determine if the dust source is anthropogenically enhanced. So the conclusion of our analysis was that the watershed has historic and modern grazing practices that are increasing the amount of sediment transported to the playa through erosion of soil and channels, breach tanks and berms, and grazing is restricting vegetation recovery. We were also tipped off to this by Department of Public Safety, who told us that the worst dust storms actually came right after heavy rains. Well, that's counterintuitive. Typically, you think that a drought would be whenever you'd have the worst dust storms. But what we figured out was happening was that after a heavy rain, it would transport a huge load of sediment from the eroded western watershed out onto the edge of the playa. And with the alluvial fans basically broken, it was just jetting a huge plume of sediment out onto the edge of the playa, essentially a new sand dune being put out there. And then whenever you have a storm coming the next day or the following days, you have all available sediment that can be entrained by high winds. The second source is the playa surface itself. Current livestock use is destabilizing the playa surface crust, increasing the amount of available dust. And I'll cover this again a little bit later. But some of it is hard as concrete, but a lot of it is extremely fragile. And once you break through the crust, there's almost no end to the amount of sediment that can be contributed. So here's the demonstration on on the right image here. These longitudinal lines running from top to bottom here are a couple of these are berms which are constructed by ranchers to prevent erosion over 60 years ago. Well, they did a good job, but they stored up several feet of sediment behind the berms. So in the left image here, you're seeing this is sediment that was stored behind the berm. So this is a modern soil structure. We went out here at the NRCS and they were surprised to see this because this sediment doesn't exist on most soil maps because it is formed in only the past 60 years. Of course, it's extremely friable and has very low organic matter. So once the berm was breached, you see this left picture, this tree dendritic erosion formation here, this tree-shaped formation. This is the water which is head cutting back up into the stored sediment. So they succeeded in storing all the sediment, prevent erosion, and now all the sediment is being ejected out on the playa surface. And on the right image here, you can see this dark plume. This is the sediment which has been relieved from the landscape here and ejected out on the playa surface. So here's the shot of this desiccated surface. You can see all these trenches within it and the playas off in the distance. Here's their shot. This is an annual fillery or biannual fillery, which is about the only thing that grows down near the playa surface. And you can see the head cut moving back towards the camera, and the sediment is being transported away from the camera out onto the playa surface. On the left here is one of the berms. You can see it's extremely eroded, and you can see a little bit farther in the image where it's been breached, and now that sediment is being transported on the playa. And then here in the center is another shot of that, and then the fence line here is separating state trust land where the camera is with BLM land on the other side of the fence. So we came up with a plan to propose restoration and land use to reduce dust storm intensity and improve roadway visibility by reducing the amount of available dust that can be entrained during high wind events. We plan to do this through the restoration of channels and the revegetation of grasslands, and also grazing management on the restoration project in the entire area. Currently, we have within the fenced area, so that is the red polygon on the left on the western side of the image. There's over 3,000 acres of primarily state trust land, which has been fenced in with cattle exclusion while we're working on a grazing plan. And then we've been conducting restoration actions within that area. We're working on a BLM programmatic environmental assessment right now, due to be done this summer. And once that's done, we plan to engage the BLM on additional restoration and grazing management practices within the remainder of the area. So now I'm going to turn it over to Bill to discuss our restoration methodology.
Thanks, Trent. As Trent mentioned, I'm co-manager of this project, and this originally started, as he mentioned, in 2014. There was a particularly bad crash where 7 people died in about 10 minutes on I-10. A dust trail came off of the playa and stopped visibility for passenger cars who stopped in the dust, and then they were run into by semi-trucks who couldn't see them stopped. So we got rolling with this with a research project, basically asking the question, could better vegetative cover reduce visibility issues on I-10? And it quickly turned into something much larger than we ever anticipated, so that that was originally going to be within our right-of-way, which is a very narrow strip along I-10, and now we find ourselves working miles off our right-of-way with state land and BLM, and it's turned into a very, very large project. But I think you'll find this interesting where we're going with this. So I'm going to talk about restoration methods. What we call KISS treatment, which is key lining. It is basically a chisel plow that has a blade that goes down 15 or 18 inches and follows the contours. We follow that with an imprinter that's a waffle stamp type machine, which creates small little mini watersheds. We'll show you images of this, and then we seed over the top of it. And then we have features for the erosion control itself in some of these degraded areas that we're doing. Next, Trent. So we have a video if you all can hear this. I'm not hearing the audio on this, Trent.
Okay, well, do you want to cover the parts of this?
Yeah,
From
so
right
this
here?
here is the tractor pulling the chisel plow you see at the very back of the tractor itself, which is ripping the soil essentially, following the contours. And then we have the imprinter, which is a roller, and that machine that's creating all the dust. And a very heavy weighted machine with angle iron that's welded so that it creates these divots, if you will. Each one's maybe 10, 12 inches square and 8 inches deep. And then seed is thrown over the top of that. And so essentially we're creating these mini watersheds, which not only capture air, but they seem to slow down the ground level wind speed. Interestingly enough, I mean, you see localized dust from this, but overall, you see dust kind of disappear in these areas. The laminar flow is reduced. Next, or maybe I can see it in operation. This technique has been used a lot in Arizona, and we're starting to use it more on DOT projects. Over time, these tend to catch low-level dust, or organic debris fills in over the seed itself, but the catchment remains, and you'll see the results we get with vegetative cover over time. A little bit more on this later, but we're doing some drone photography down there, and we've been working with a photographer by the name of Esha Chio, and she works for National Geographic and has a separate grant from them to document this project. So you'll see this is following contours. Basically, the change in albedo is what you see with the colors between the light and the dark with the turned soil. But very sophisticated approach with this, really reading the land as we go along and treat these areas. It almost looks like the plains of Nazca here, except you can't identify what the things are we're creating. But essentially, we're trying to, again, arrest the flow of water across the land surface, arrest the development of head cuts, allow the water to percolate where it is instead of running off and creating these erosional features. You get a good idea of it. Here's some background information on Esha. She has had a show here in Santa Fe. There's a few more images there at the bottom, which we'll show in the subsequent slides, but you get a good idea of what these dendritic erosion patterns are like. Working the fence line between BLM and state trust land there. You can see to the left, here is, we call these cauliflowers, but essentially they're dendritic patterns. And so we're trying to arrest the head cut as it moves on by getting vegetation there to hold the soil as it wants to head cut back up. Again, more imagery of this. So we'll show you some examples, essentially before and after, as we do this KISS treatment on these degraded areas. This is typically what we get. The seed, we do a mix of obviously arid appropriate species for this area. As a sidebar, we have had a research contract in developing local seed varieties using the BLM's national seed strategy, and those are going to be ready for release in our own projects next year. But that entails going out and selecting totally indigenous varieties for this area and selecting them for good qualities and then releasing them to commercial growers. What we have learned from our work is that we tend to get far better results initially from what is called relic seed, and that is the seed that's already in the soil from hundreds, thousands of years put down by native plants. The soil is full of it down there. And we often, what you saw in that picture is something called 6 weeks grama, which is prevalent. It's an annual grama, which comes up very prominently. Cattle love it, by the way. The next shot here, Trent. And again, before on the left, after it's been the kiss treatment, and the right, we get kind of a variety of different things growing. I mean, for intensive purposes of erosion control, we have success with this. What we are looking for is more stable, deep-rooted perennial grasses, yet to show up down there in any great abundance, but we believe through succession we will get there eventually. We did have 1 year during these periods when we got a lot of rain and we had cover even without erosion control measures, and we proposed to the BLM that they close it to grazing, but they weren't having it at that time. But there has been a sea change with some of the BLM approach that you all may be aware of, that conservation is now one of the things that they will support. So these are the other set of things that we do, which this is called a plug-in pond. So we identify areas where a judicious, basically damming of water, and that has head cut and store that water and allow a way for it to flow basically around, but retain it, sort of a mini check dam, if you will, and restoring the sheet flow of water across land. So on the left, it's hard to believe, but on the left, that's what that looked like before. And on the right, of course, rainy season. So everything lushes up down there, but you can see the result of that, and there's still standing water on the site. And these are many rock check dams that we do, which, as indicates, stops down cutting, restores sheet flow and infiltration. Very time consuming. We have amazing crews of folks working down there, very dedicated under what you might imagine are very challenging conditions down there. And thousands, I believe, at this point, of check dams have been installed. And of course, they do silt up, and in essence, you need to come back and keep doing it because you may raise those grades, but it also captures that soil, which acts as a sponge and provides a good area for vegetation within the channel itself. And this is satellite imagery showing within the images that we showed earlier, mostly BLM land, but there is a state trust land parcel in the middle of the playa, and state trust land manages theirs differently in that you're allowed to augment feed with water and feed out on these places. On BLM, you can have water stations, but you can't bring extra feed. On state land, you can. So a particular rancher has leases on both, and he has this feeding station, which you can see from a satellite. Those are cattle on the upper right image. Those black dots are cattle, and they are creating these trails which go out. And this is a hazard to say main source of dust affecting operations on I-10 over time. So it's one of the things we're trying to work with these agencies, is to reduce this approach with it. Our analysis indicates that the playa surface itself is not a good place for cattle grazing. And we'll go into that later, but if the crust is broken, it liberates the dust underneath, which is like talcum powder. It becomes airborne very, very easily. And there's almost nothing for cattle to eat out there unless they were augmented, fed, because this is submerged at times. So vegetative cover has a hard time getting going to begin with.
Yeah, so here on the left, you'll see cattle trailing. This is through what we call the playa steps. It's the Pleistocene lakeshore. This is an extremely fragile area that we are afraid to even attempt to restore because, as Bill said, it is like talcum powder. So this is highly erodible. So this shot in the middle, this is a hole that we dug through the crust. You can see there's several inches of hard crust, but underneath there's feet, foot after foot of completely loose, uncompacted silt and sand mixture. So if you do break that crust, which you can see on the far right image, that's just the, one cow moving through this area and the amount of crust that they break through there. That once you start the process of, removing the crust, that it can just, the wind will continue to erode even if you don't continue grazing. So luckily we have been working or not luckily, but through very hard work, we've been working with the BLM, State Land Office, and in cooperation with the grazing lessees to implement a grazing plan to prevent erosion and increase restoration. So we're in the process of working on that now and are excited by some recent progress that we've had, especially working with the BLM. So some metrics on what we've done so far for phase 3. So the blue area, so this is the fenced area that we have that's all state trust land. The blue area is the completed KISS treatment. So that's the key line, imprinting, and seeding area. The green is proposed additional KISS areas. And then the dots that are within there are different forms of erosion control structures, both proposed and completed. There have been over 1,500 erosion control structures completed, over 1,200 acres imprinted and seeded. And so far, the result of it, it seems like we have arrested erosion within the Western watershed. Of course, there is still erosion. There are still elements of it, but widespread erosion, which was transporting sediment to the playa surface, seems to be at this point largely arrested. So a critical element we're working right now. We've already nominated it once. We're renominating for this area to be BLM designated an area of critical environmental concern. That allows for special management conditions within this area. Because right now, this is, even though it looks like a big playa, this is just a pasture with a number on it. So the criteria to become an ACEC, the relevance is a natural hazard, this being unstable soils, caused by human action may meet the relevance criteria determined as become part of the natural process, which in this case it clearly has. Importance, that it has qualities that warrants highlighting in order to satisfy public or management concerns about safety, public welfare, imposes a significant threat to human life and safety or property, which this is one of the most dangerous natural hazards in the United States, even though people typically think of, volcanoes or flooding or elements like that. But this is an extremely dangerous natural hazard that has largely been overlooked. So the importance of this becoming an ACEC is really illustrated by the fact that there are 2 lithium brine mine proposals that have been submitted to the BLM and State Land Office and other regulatory agencies proposing extraction wells on the playa and the other elements of industry that would come along with it. Of course, we have been highly critical of these just because of the potential to increase the amount of available sediment within the area. And we'll have to see whether or not these pan out or what comes of this. So as far as funding, briefly, 3.9 million from FHWA, safety improvement and new protect funding, part of the bipartisan infrastructure program for resilient infrastructure. So we've used that for dust mitigation actions. Over 185,000 through our research bureau. Originally started with just NMSU, and currently, and this is the following presentation, will be about the research partnership that we have right now with USDA, Hornado Experimental Station, and NMSU to work on our and their dust monitoring within the Lordsburg Playa area. And then, as Bill talked about earlier, funding for seed development for restoration purposes. So collaboration with our consultants, the BLM, State Land, DPS, the landowners, our own elements within the DOT, the NRCS for their excellent updated soil survey, and then NMSU and the Hornado. So try to wrap that up, see if we have a minute for questions here.
Trent, can you comment on the number of fatal crashes since your project started at the playa?
Sure. We did have a spike from 2017 to 19 was a series of, and the crashes definitely coincide with the La Nina, El Nino cycle. You know, there's wet periods and people forget about the crashes on the playa. And then there's, you know, dry periods and they start up again. So, but since 2019, we have not had any fatal crashes on the playa. Last year, we did have a pile up going in both directions from a very brief zero visibility event from an area that we had not identified yet. So a source dust area that had not been identified. But we credit the lack of fatalities with the fact that we had extensive warning systems out, flashing lights. We have digital signage, recommended speed decrease. And so when the pileup did happen, people were not traveling 80 miles an hour. And so that is another critical element which DOT District 1 has been instrumental in really getting the warning system out to make people aware of it.
We haven't had a fatality since 2017 out there.
Okay, thank you.
And so we do have one question here in the audience here in person, and I'll go ahead and hand the microphone to him. You go ahead and speak into the.
Okay, great presentation. I am curious, have any high wind events negatively affected the establishment of these projects?
No, not really. I mean, it's part of the natural environment. We're trying to build into natural systems to restore the natural systems of sheet flow, of soil infiltration, you know, precipitation. So far, you know, I mean, certainly drought, there's nothing we can do that will make something grow whenever it doesn't rain. But the erosion control and imprinting, even after the imprinting areas had been there for several years, and it looks like they've kind of almost blown away. The imprinting structure, that grid pattern remains within the soil because of the weight of the structure that goes over it. So that's still there and it still creates nurse areas for vegetation recovery. And whenever you do finally get rain, you'll see it come up in a grid pattern, even 3-5 years later, will still come up in that pattern where the imprinting and the seeding occurred.
Okay, great. And one other question I have is, with the BLM's increased focus on conservation, do you see more opportunities for projects in the future?
Definitely. The BLM Las Cruces office has been very supportive of this. They really like our high intensity, small structure technique of healing a landscape. The traditional method is to build a big siltation pond at the bottom to gather all the sediment that you then have to clean out over time. And those have been proven time and time again to not be effective. So regionally, there has been a lot of interest in this watershed restoration technique. The other thing about it, you know, we work in major transportation projects. We've spent less than $4 million on this so far. We've restored thousands of acres. It's hand built. It's very cheap work. It's cheap materials. It doesn't have to be engineered, although it is laser level surveyed, and we also have LiDAR. So it is technically designed, but it doesn't have to be engineered. And so the amount of money that you're saving through lack of design, heavy materials, heavy machinery, you know, thousands of cubic yards of concrete, wire wrapped, riprap is enormous. So you can recover enormous amount of landscape for the amount of money that you would spend even just designing it. And there's another question here about KISS work this summer. So we do the KISS work in late fall through winter during the lowest wind speed time, so we don't end up generating dust events accidentally. You know, dust events can pick up at any time during the summer. So the summer is our down season, And we'll be going back. We also have an extensive vegetation monitoring program, which the Coronado may cover to track our progress within this. So that usually gets completed at the end of the growing season in September. And then as we get into late fall, early winter is whenever we do the additional erosion control and KISS work.
And I know we're running out of time, but I'll just add, Trent, that we, as part of the environmental process, we're intending to follow through on an earlier nomination. The BLM has a land status called an area of critical environmental concern, and we are going to reapply for one of those for this area, which would basically generate a special management plan for the playa itself. It doesn't have a jurisdictional status with them now, but that's the big prize that we're looking for to try and protect this area and use more appropriate land uses for it.
Great. Thank you for your presentation and I mean all the questions as well that all of the participants had. That was a very good session that we had right there, and update as well. Those patterns are pretty interesting to see it from a drone view. I'm kind of thinking, why didn't I think of that? Pretty interesting form of art that they were able to do for that as well. So we're gonna go ahead and go to our next presenter with it's also talking about dust mitigation efforts at the Lordsburg Playa with New Mexico State University. And we have Robert here. I'm gonna go ahead and let him introduce himself and present as well. Go ahead and bring up the presentation.
Thanks, Armando. It's great to be presenting after Saroj and Bill and Trent there, because we sort of saw a national or global level view of dust events and got some great background on the restoration efforts at the Lordsburg Playa. And so I'll be continuing to talk about that a little bit, as well as providing a more local view of these Southwest dust events. So Brandon Edwards and myself are both researchers at the Coronado Experimental Range. And as Bill and Trent mentioned, this project's been going on for a while. Our monitoring efforts here have really took off around early 2023. And I'm gonna just provide a little bit of project background here. So broad strokes, we've been tasked with collecting meteorological data and studying the dust ecology at 3 sites on the Lordsburg Playa. Our 3 sites are all within this red square here, and this is just a map orienting us. There's Lordsburg in the top right, and that dangerous stretch of I-10, and then the Arizona and New Mexico state border on the left there. And here's a closer up view of our 3 sites. So we have one site north of the playa, about 4,000 feet north of I-10. That's our North Playa site. And we have 2 sites on that Road Forks Playa that I think Trent mentioned briefly. And 2 sites there. One is called Road Forks Treatment. One is called Road Forks Reference. And the treatment site has had some restoration efforts happen nearby. And it's also a rather disturbed area in the past, whereas the reference site represents more of a control site for the area. So one of our tasks is to measure horizontal and vertical sediment flux, and we do that with a variety of instruments at these sites. Each of the 3 sites have 10-meter Met towers, 2 of which you can see in the photos on the screen. And these Met towers are used mostly are used to measure vertical flux. The image on the right shows a list of the instruments, of some of the instruments that we have on the towers. So at the very top of the tower, we'll have a met station where we can measure things like wind speed, direction, temperature, lightning strikes, and a few other variables as well, I think. We have sonic anemometers to measure wind speed at 1.6 and 4 meter heights, and particle counters. At this tower, they're at 1 and 3 meter heights, and at our North Playa site, the heights are a little bit different. But this allows us to measure gradients and vertical flux and other meteorological conditions. And then to measure horizontal flux on the image in the lower left, that shows sort of an array of what are called these MWACs. So these are 4 aluminum cans on a fin, which help to measure the horizontal flux profile. We have 12 MWACs at each of the Road Fork sites and 27 at the North Playa site. So the Road Fork sites are about half the size of the North Playa site, but there's 2 of them. The North Playa site has 27 and generally follows the protocols of the National Wind Erosion Research Network, which I'll be talking about in a bit. Another thing that we've been tasked with for this project is being able to estimate and predict sediment transport and dust emissions at a variety of areas along the playa. And the way that we would do this is by modeling, and the way that we could parameterize such a model is by collecting a variety of environmental data. The image on the right sort of shows the vast array of controls and things that can affect sediment flux. And the 4 bullet points there are there to show the data that we would need to collect. And for each of those 4 bullet points, I'd say that we're at sort of a different level of actually collecting and analyzing this data. So things like horizontal sediment transport and vertical transport and aerosol concentrations, we've been, we have about a year's worth of data for that. And those monitoring efforts are definitely up and running. Things like environmental conditions, like soil moisture and crusting, is something that we're beginning to collect. And same with vegetation, community composition, and structure. So for Brandon and myself, we are going to be running transects on the 3 sites I showed, but we'll also be incorporating the monitoring data that Trent mentioned that some of those crews are collecting at other areas on the playa. So before I dive into our 3 sites, I'm going to zoom out to provide a little bit of regional context for flux rates in the area of southern New Mexico. So the map on the lower left there, there's 3 colored dots, each representing a different National Wind Erosion Research Network site, or NWERN site. So there is also an NWERN site nearby our North Playa site in Lordsburg. The blue dot represents the Jornada NWERN site, and the red dot represents the Tularosa Basin NWERN site. And so just broadly, you can see that the Lordsburg Playa site with the bar chart there generally shows higher rates of flux for any given month. And this data represents a few years worth of data for each of these sites. And it's been collected and organized by month there. So I've marked out what I'm calling kind of our windy season from January to June. You can see a big spike in February, but the biggest spikes occur during the monsoon season. And that pattern is generally visible across all the sites. The reason for why Lordsburg Playa is so much higher than the other 2 sites is perhaps due to vegetation differences and maybe slight variations in climate as well. And the vegetation differences is likely a lack of vegetation at the Lordsburg site compared to the other sites. And so I'm showing a similar but slightly different chart of our 3 sites in Lordsburg. So whereas the previous chart showed the data organized by month, this is basically just a year's worth of data and then showing a daily flux rate for these sites. And the y-axis is slightly different as well. So it's just showing relative differences in flux for North Playa, Road Forks reference, and Road Forks treatment site. North Playa is showing the least amount of flux, and Road Forks treatment showing higher rates of flux. And this is likely due to, this data appears to be negatively correlated with vegetation cover at these sites. As I mentioned, we're just beginning to collect vegetation data, so hopefully more to follow on this front as our project continues. And continuing with providing context and just general meteorological information for our site, I have a windrows here showing a year's worth of wind data for our road fork treatment site. The map on the bottom there, just reorienting you to where that site is. Apologies for the text being cut off. This is from May 2023 to April 2024. And just to explain this diagram, because I'll be showing a few of these, the length of each paddle represents the percent of records with the paddle's direction. So on this windrows, you're seeing about 20% of the records come from the due west. And then wind speed, the range of wind speed is represented by paddle width and color. And the way the windrows here is it's organized in 0 to 2, 2 to 4, 4 to 6, and 6 to the maximum record meter per second based on the width and color of the paddles. So now actually talking about the windrows itself, we can see that for basically the past year to date, the most prominent wind direction is from the west, both north and southwest, and then there's also a strong current coming in from the southeast. Oops. So if we break that out by month, we can see some of the seasonal patterns. So just looking at that's a windy season from January to June. This is where a lot of that western winds comes from in the yearly windrows. And then if we look at the monsoon season and into fall, you see a lot more variability in the monsoon season in July, August, and September. And then in October, November, and December, there's a strong southeastern current coming in. And one last physical characteristic of the Road Forks treatment site I'll talk about here is fetch. And the reason I'm focusing on this site so much is because pretty much almost all of the data I'm going to show is from this site because it's the one that we got up and running the soonest in this project. Fetch here, I'm really just defining as the area of bare ground you travel before reaching an area of relatively higher roughness. So for our north direction here, we hit I-10, as you can see, in about 100 meters. The easterly direction has a fetch of 250. Southeast is our longest fetch distance at 530 meters. South is about 300 meters. And the west and southwest directions are roughly 200 meters across the playa. So I'm going to make a little bit of a digression here, rather than just talking about dust events, to talk about non-transport related particulates, since our Road Forks treatment site is so close to a highly disturbed area of I-10. And these two graphs, or these two windrows rather, demonstrate the effect, I think anyway, of non-transport related particulates in our data, which is just something worth keeping in mind when looking at these data sets. So the windrows on the left shows all wind speeds over 8 meters per second and has nothing to do with particulate count, just really strong wind events. And the directions of west and southeast are really strongly represented here. The windrows on the right is not looking at wind speed, but rather just looking at particulate records. And so that rather the top 2% of particulate records, which doesn't necessarily always mean that visibility is strongly reduced, but just that there are at least a lot of particulates in the atmosphere. So the western and southeastern directions are still well represented here, but there's also a very strong component from the north. And it's worth remembering that any winds blowing from the north will of course have to cross I-10 and a relatively disturbed area. And I have the same type of charts here for the North Playa sites, just to demonstrate that effect as well. So on the left is the high wind speed windrows, which has even more winds from the west. And on the right is the high particulate counts windrows. The effect is attenuated. You do see there that the southern direction is more strongly represented on this windrows. And that effect may be attenuated just because the NP North Playa site is about a little less than a mile north of the interstate, whereas the road fork site is just a few hundred meters south of that. So yeah, just an interesting aspect of these sites, but not something that I think is really overwhelming the data as I present it. So now I'm happy to move on to talking about the more exciting part of this presentation, which is dust events and weather patterns, and lots of nice photos to come. So this map here is just to reorient us where we've got North Playa site, road forks treatment, and road forks reference. I'm going to be showing photos and data here. The photos I'll be showing are looking southeast across the interstate. The data, however, is going to be coming from the road forks treatment site. So again, this is kind of due to us getting these projects up and running in this past year. So there's some data gaps, but I think it works out nicely because the North Playa photos show a great general representation of the area around the road fork treatment site. So I'm now going to go into 4 days throughout the past year where there were significant dust events. First event I'll be talking about happened in fall. So between October and December 2023, there were several dust events that seriously reduced visibility. And just showing those wind roses again, that this period of time is characterized by winds from the southeast direction. Now, as I mentioned in that fetch diagram, there is a large fetch at the south-southeast direction, and we did see some dust being detected at road forks treatment with winds from this direction. But generally, the reductions in visibility are usually associated with western winds and/or rainfall at this site. The first event I'll be showing is from November 16th, and I'll be showing a few charts like this with daily weather data. So on the top row, we have wind speed and wind direction. In the middle row, there's 1 meter particle count and 10 meter temperature. And then on the bottom left is rainfall. So just walking us, I'll just walk through this day. So we see a pretty typical ramp up in wind speed from the morning to the afternoon. The wind direction stays solidly from the western direction, which again is a little bit unusual for fall because we more normally see a southeastern wind direction. And there's a pretty clear particle count spike at around 2:45, 2:15 p.m. that corresponds with the highest wind speeds. And the temperature curve is pretty normal, and no rainfall was observed with this event. On the right, I've pulled up the synoptic map for the region.
Okay, we're back online. Are you able to hear us?
Yes.
We're back online. Do you hear us?
Yes, we can, and we can see the screen.
But now we don't hear you.
Hope you enjoyed that brief intermission. Getting back to it. Okay, so I was just walking us through the weather for that day, and we're just going to show the synoptic map here. So this map shows a cold front moving through the area, or it had moved through the area by around 12 p.m. that day. So the dust event itself was preceded by a cold front moving through. And now I'm going to show some photos from that day, just stepping through the wind speed graph of that day. So oftentimes on really dusty days, early in the morning, we'll see, even when wind speeds are relatively low, you'll start to see entrainment and little hot spots pop up on the playa. The red arrow on this image there is just showing a cloudy area of dust on the playa at 11 a.m. And you can see there's a related spike in wind speed up to 8 meters per second at that time. By 1 p.m., the winds were solidly at about 10 meters per second, and a more persistent haze was beginning to form. And then at 2:45 is the spike in wind speed, or almost the maximum wind speed for that day. And this was the spike in particle counts. So there's a pretty severe reduction in visibility here, but the skies are still clear, and even though the winds are consistent, the sky may still be clear because this event wasn't really associated with a significant rain event or a front moving through at the same time. So now moving on to what I'm calling the windy season from January to June, and the wind roses here show that strong western wind pattern. So that is characteristic of windy season events. Events will also often start in early afternoon, and these are often associated with cold fronts, as I'll show. Here's our second event for January 7th of this year, and this is a very typical pattern where early in the morning till around noon, wind speeds are fairly low and kind of gently coming in from the north. And then right around in the afternoon, wind speeds ramp up significantly. The wind direction starts coming in strongly from the west. There's a very clear resultant spike in particle count as well. And it's a little bit hard to see on the rainfall graph, but there's a small bump in rainfall after 5 p.m. that day. And the synoptic map shows why a little bit. So at noon that day, there's just a low pressure system visible over in New Mexico. But by 9 o'clock, you can see that a cold front has been moving west that entire time and is about to reach the Lordsburg area. So this event, unlike the previous event, which was preceded by a cold front, this dust event precedes a cold front that is moving behind it. And so here's our photos from the North Playa site looking southeast. So it's a little bit hazy at 11 a.m., although the winds are still quite low. By 1 p.m., you're seeing nearly whiteout conditions, along with wind speed reaching its near maximum. And conditions clear by about 4 p.m., although winds are still quite strong. But you can see clouds start moving in, and then that evening is when the precipitation starts to fall. And I believe this was rain, but it may have been snow or hail as well. Our next event is also in the windy season, but a few months later, March 7th. And this is an event that's near and dear to Brandon and my's heart because we were actually out in the field for this one. And it was quite dramatic. So this also shows on the wind speed a typical ramp up from the morning to the afternoon. But all of the charts kind of go haywire a little bit around 3 p.m. So wind speed drops rapidly and then speeds up. The wind direction is also moving all over the place, and a strong spike in particle count and a massive drop in temperature as well, from about 15 degrees Celsius to 8 degrees Celsius. And the rainfall chart shows a couple different spikes. Looks like there's one around 2, 3, and 6 p.m. that evening. And the synoptic map here is pretty revealing because it shows that at 3 p.m. that day, which is when all of our charts start moving crazily, there was a cold front that sort of turned into a stationary front, almost right over Lordsburg, right at 3 p.m. that day. So at 12:30, it was clear, relatively clear, although there's a little bit of dust you can see getting emitted on the playa as the winds start to pick up. At around 2, we see the rain started to come in. And this is a cool photo because you can see that, I think sort of more in the foreground, you can see there's some rainfall, but in the distance at the base of those mountains, you see a little bit of white haze. So I think that's showing dust transport maybe ahead of the rain that's moving across the playa. Then these two photos are, the top one is from 3 o'clock and the bottom one is from 3:30 that day. The top photo is basically showing the weather pattern directly over us with hail actually falling. And at 3:30, you can see the pattern has moved east across the playa. And this is also peak wind speed as well. And then to show the sediment transport, I think I have a video, or I should have had a video, but I'm not seeing it show up. Oh, okay. I'm not sure what's happening, but I think this is a still from a video that Brandon took that day. And very, very revealing. You can see that I think there's dust and rain in this image as the winds are swirling around along with the rain that's coming through the area as well. And I should note that I was safely ensconced in the work truck at this point, and Brandon continued to diligently work on the tower. This photo is, I think, from 5 p.m. that day, and so the weather did a great job of basically ruining our field day, and then almost just a few minutes later, it was almost completely clear. So fun times on the playa that day. The final event I'll talk about is a monsoon event. So the wind roses there show the increasing variability of wind direction in July, August, and September, whereas June still shows that strong western pattern. So these monsoon events are often driven by high pressure systems in the Four Corners region. The events occur more often in the late afternoon, and they're highly dynamic and spatially variable systems. The data from these days has definitely been interesting to look at. And so the day I'll be talking about for our fourth event occurred on July 21st, 2023. And it's the wind speed pattern is very characteristic of a monsoon event where you have low wind speeds throughout the day that rapidly ramp up in the evening as the monsoon pattern moves into the area. The wind direction was fairly variable throughout the whole day, although it sharply tracks to the north when the weather pattern moves in. I think this is the highest particle count I'm showing, and you can see how it basically hit the maximum level for what we had our instrument set for as the weather came in of 8,000. And you also see the temperature curve drops off as the weather pattern moves in around 5 o'clock. Worth noting, there was no rainfall observed at our site that day, and I didn't even see rainfall records in Lordsburg for this day, but the photos will show that there was rain in the area. It's just, of course, quite variable spatially. And here's a synoptic weather map showing the areas of high pressure around that Four Corners region and the characteristic low pressure in the Boot Heel region. And this was from 12 p.m. that day. Sort of just an establishing shot showing the hazy summer conditions and gentle wind speeds over the playa. These next few photos, I was able to pull in photos from our Road Fork site as well on the bottom left. So that's looking east across the thruway. So you can see the weather beginning to move in and the skies are darkening in the upper right image as well. And that was at 5:15. So at 5:30, you're seeing pretty dangerous conditions as that particle count starts going above 8,000 and the wind speed is hitting 15 meters per second. And here's another photo at half an hour later showing those conditions were maintained for some time. So to summarize these events and more general weather conditions in the area, See that the fall winds of October and December tend to be weaker than the windy season, more frequently come from the southeast direction. There's a photo from North Playa, I think, of just some fall winds and some entrainment. The windy season winds from January to June are more frequently from the west, and there's some photos looking over the northern parts of the playa in spring 2023. Dust events tend to be related to western and northern winds, and they often are associated with rainfall as well. And the monsoon season shows high directional variability with dust events associated with monsoonal weather patterns. So for our next steps, we hope to continue monitoring weather and particulates, but across all sites. So I mentioned that the Road Forks treatment site is the one that we got up and running the fastest, but we're also getting data from North Playa and the Road Forks reference site, and looking forward to incorporating that into our analyses. And with that data, we're hoping to further develop the dust climatology of the region, as well as associate representative dust events with climate patterns. So sort of like I was trying to do here, but in more detail and with more information. And then using this collected data, as well as the field data that other crews have been collecting in the region, we hope to incorporate alien sediment transport and dust emission models into analyses of these weather patterns and to begin to predict and potentially simulate dust events in different areas of the playa. And I don't have an acknowledgements slide, but I'd just like to thank NMDOT and the Jornada Experimental Range, as well as the Plant and Environmental Sciences Department of NMSU. So thanks, and if there's any questions, go ahead.
All right, thank you, Robert. Just wanted to see if anybody has any questions for Robert on the online platform or in person. Yeah, those fall winds, we definitely get influence from those backdoor cold fronts, and so that's where we commonly see our exceedances coming from. Like when we start getting those like the dust influences from like the plains area, and then just like during the main fall, I mean the main spring windy season. I mean those are, I mean, we're getting a lot of those Pacific cold fronts coming in, and those pretty high scale and region wide, unlike the monsoonal events during the during the summer months when it's pretty very sporadic and it's kind of hard to predict, and I mean it's just kind of depending on where the outflow conditions are. So yeah, it's some great work that you're doing, and appreciate you coming in today for us today. Thank you. And so we're going to go ahead and go on to our next presentation, and it's going to be going to be Alan Smith from the city of Albuquerque. He's going to be presenting about the draft Albuquerque-Bernalillo County Dust Mitigation Plan, as well as the fugitive dust mitigation plan requirements.
All right, thanks, Armando. So I'm from the City of Albuquerque Environmental Health Department Air Quality Program, and I'm going to be talking about the fugitive dust mitigation plan that we developed, and actually it's no longer a draft now. We recently submitted to EPA last Friday, so I'm going to speak about that. Okay, so going through kind of the general outline of the presentation, I'll talk about the exceptional events rule under the Clean Air Act and how it requires mitigation plans for areas that meet threshold requirements. I'll talk about the mitigation plan requirements under the Clean Air Act and as well as the periodic review period for that mitigation plan and some of the measures that are in it. And so under 40 CFR 51930 under the Clean Air Act, there is, there's an exceptional events rule, and there's also, as part of that, certain jurisdictions are required to submit mitigation plans. And generally that rule calls for all states or local jurisdictions. And just for a little background context, the City of Albuquerque Environmental Health Department covers Bernalillo County, is the regulatory jurisdiction for Bernalillo County, whereas the New Mexico Environment Department is the regulatory jurisdiction for the rest of the state. So all states or local jurisdictions having areas with historically documented or known seasonal events shall be required to develop a mitigation plan with the components outlined in under the rule and submit the plan to the EPA. And so for more background, in April of 2022, the City of Albuquerque Environmental Health Department was notified that Bernalillo County is subject to mitigation plan requirements under the exceptional events rule due to recurring exceptional events for PM10, looking at data years 2018 through 2020. And EHD, we worked with the University of New Mexico School of Public Health to get some research on measures that may be good to include in the mitigation plan, as well as recommendations. And we also worked some with NMED staff to obtain some recommendations on best practices to include in the plan. The Bernalillo County dust mitigation plan was largely drafted based off the NMED's plan for Doñana and Luna counties, which Armando is going to talk about after this presentation. And so there were certain recommendations that were included in the final mitigation plan, including continued enforcement of our fugitive dust rule, which is codified in the New Mexico Administrative Code under Part 20, specific to Bernalillo County. And we are currently working on a process to amend that rule, so that is ongoing. And then as part of the mitigation plan process, as well as the rule development process for the fugitive dust rule, we are engaging with stakeholders and looking to engage more with stakeholders. We're looking into natural stabilization techniques, more education, prioritization of mitigation efforts in certain high-risk areas, maintaining or increasing vegetative cover to reduce erosion of soil, as well as use of natural windbreaks, in addition to mitigation for construction projects, which is a big part of Part 20. And while some staffing and time limitations precluded EHD from going too in-depth on certain topics for this mitigation plan, we feel like it does provide a good framework for periodic revisions going forward to strengthen the plan. It is reviewed every 3 years. And again, we have started a process to amend Part 20. And so, and going to the dust mitigation plan requirements, pursuant to the exceptional events rule, the requirements include, for any mitigation plan, it has to include public notification and education programs for affected or potentially affected communities. It needs to include steps to identify, study, and implement mitigating measures, including approaches to address each of the following. Measures to abate or minimize contributing controllable sources of identified pollutants, methods to minimize public exposure to high concentrations of identified pollutants, processes to collect and maintain data pertinent to the event, mechanisms to consult with other air quality managers in the affected area regarding appropriate responses to abate and minimize impacts, and then finally, provisions for periodic review and evaluation of the mitigation plan its implementation and effectiveness by the state or local jurisdiction and interested stakeholders. And so with the submission of the initial mitigation plan, we did make the draft mitigation plan available for public comment for 30 days, and it was available on the website. And we did submit any public comments received along with the mitigation plan to the EPA. And so in the submission to the EPA, for any public comment received, the mitigation plan explains any changes made to the mitigation plan or why the state or local jurisdiction did not make any changes to the mitigation plan. And then the state or local jurisdiction in its mitigation plan must specify the periodic review and evaluation process that it intends to follow for reviews following the initial submittal. And the plan did specify a review period of every 3 years. And then, when we got the notification in 2022, states or local jurisdictions generally have 2 years to submit a plan following notification of the requirements or the notification that that jurisdiction is subject to a mitigation plan. And so the mitigation plan does discuss our current fugitive dust regulation, and as mentioned, is being evaluated for possible changes. And that regulation does include programmatic and construction permits as part of it for certain disturbances that disturb 3/4 of an acre or more. And programmatic permits are valid for 5 years, whereas construction permits are valid for 1. And every construction permit application must include the total volume of bulk material being handled, the total area of disturbance, a project description, the anticipated project completion date, a site map, high wind contingency measures, as well as a description of any stockpiles. And in the Part 20 regulation, it does include a section on reasonably available control measures, and each plan, as far as part of a permit application, needs to include some of these. And those measures include wet suppression for construction projects to reduce particulates, the use of dust suppressants, and the amounts, frequency, and rates recommended by manufacturers to help stabilize sites. That can include, so some permits, a reduction in vehicle speeds on unpaved roads, the utilization of windbreaks, such as fabric fencing or other methods to stabilize stockpiles or other types of natural windbreaks. The reasonably available control measures can include a restriction on access to stockpile areas during non-work hours. It can include a maintenance of stable outer crust to inactive stockpiles, as well as the use of xeriscaping. And the mitigation plan does discuss some voluntary measures as well that are kind of best practices to include in any kind of dust mitigation effort. And so the Department of Agriculture, NRCS, the Natural Resource Conservation Service, does have a best practices manual for agricultural cropland, rangeland, natural areas, and unpaved surfaces. And some of those control measures can include maintaining soil surface cover, agricultural practices aimed at improving soil health, reductions in the amount of driving that a vehicle does on that land, natural wind breaks and vegetative barriers, as well as other methods for unpaved roadway management, such as use of water. Those best practices include reduction of reliance on commercial fertilizers, land application of compost, and improved pasture and range management. And Additionally, the Department of Agriculture does have a healthy soil program where soil and conservation districts can apply for grants to improve soil health. And the program can also distribute recovered crop seed to local agricultural operations and help land managers evaluate soil health. So these are excellent programs that we encourage land managers and local farmers to take advantage of. And there are a lot of small farms in Bernalillo County that are using some of these best practices already. And so some of the other recommendations that were included in the mitigation plan include fire suppression efforts and invasive species management. There are currently ongoing projects in Bernalillo County with the city to help reduce the amount of invasives in the bosque and reduce fire risk, as well as even using goats as part of those efforts. And that just overall helps with creating a healthier ecosystem that's more resilient to climatic changes and thus is less likely to produce erosion. And integrated vegetative management, I know the Department of Transportation has talked about a lot of their projects, and that was one focus on right-of-way areas and other areas as seen in Lordsburg. And so we hope that some of those DOT projects could come to Bernalillo County as well. Some of the research from the University of New Mexico talked about bacteria-induced biocrust stabilization methods, which can take a while to establish, but those projects could be worth further consideration in future periodic revisions of the plan. And then we also in the plan talked a little bit about methods to reduce exposure during high wind days that result in high particulates, including health alerts. We do have a good system in place, as well as reducing exposure to outdoors, wearing masks, closing windows, just best practices to reduce health impacts during those particular events. And we do have 6 ambient air monitoring stations, including 5 federal regulatory monitors equipped with instrumentation to track windblown dust. And all 6 stations contain instrumentation to measure meteorological parameters relevant to particulate matter transport, such as wind speed, wind direction, and temperature. And weather and data forecasts are monitored to determine conditions for health alerts and stop work orders. We do have a meteorologist on staff at the department that helps with that process. And generally it's called by the meteorologist, but if there are sustained winds of 30 miles an hour or more, generally a stop work order is issued for active projects on those really high wind days. And so some of the education outreach efforts, so we do have a dust training workshop twice a year for permit holders. It includes topics such as regulatory oversight, importance of controlling dust, the permit process, standard dust controls, as well as their alternatives and innovations. And then, I have been attending some of the Dust Alliance of North America webinars, and so the hope is that will continue with the department attending those. And then we do participate in city events to educate the public. For example, we were at an Earth Day event Sunday in Albuquerque. And we do have the high wind warning system and notifications. The public can sign up for health alerts and get those notifications when the meteorologist determines that particular conditions warrant that. And then, as I stated earlier, we do plan to review the dust mitigation plan every 3 years. So there are opportunities to strengthen it and add more things. And I'm happy to take any questions.
Just want to know if there's any questions for Alan, both virtual or in person.
So Alan, what kind of changes you can make to part 20?
Do you have a question, Neil?
Yeah, what changes is Alan planning on making to part 20?
Daniel?
I think Neil has a question for the speaker for Alan. Maybe you can answer that first, and I will ask my question. Okay, so I will go ahead and ask my question. My question is, you have this
I'm
nice.
not able to hear you.
Can you hear me?
We can hear you on the platform. I don't know if Armando can hear you.
Okay, so it looks like they're having problem listening to hear me. I will type my question.
Yeah, I'm not able to hear.
Can you hear me now?
Okay. Dr. Tong,
Yeah, can you hear me?
have you unmuted?
I'm unmuted. But it looks like you still cannot hear me. I will type.
Yeah, we're still not able to hear.
Can you hear me now?
Okay, so we do have the question in chat. So the question is, 6 monitors, how do you identify the dust events?
Thanks, Daniel, for the question. So our meteorologist is the one that makes the determination of that, and that would probably be a better question for our monitoring staff or our staff meteorologist. So yeah, that's kind of a case-by-case determination based on a lot of factors that the meteorologist makes in determining whether to issue a health alert.
And so the other question too is, what type of changes are you proposing for part 20?
Good question. We're currently having discussions right now. Internally, it's kind of early in the process, but pretty much everything is on the table. We are looking kind of internally looking through each section and discussing what needs to be updated. And so yeah, it's kind of too early to tell, but yeah, happy to keep you posted as things develop more.
Great, thank you for the questions. Are there any other questions for Alan? It seems like we got knocked off on the sound online. So if you can be able to type your question in the chat. If not, we'll go ahead and go on to our next presentation. Just myself. Okay. Today I'm going to be talking to you about the Doñana and Luna County Dust Mitigation Plan. My name is Armando Paz, an environmental analyst with the New Mexico Environment Department Air Quality Bureau. I'll also be talking about the fugitive dust rule as well. And so a little bit of overview as far as the National Ambient Air Quality Standards, exceptional event rule under 40 CFR parts 50 and 51. A little bit of the public health protections, as well as our dust mitigation plan revision, and some information about our fugitive dust rule. And so we do have a total of 6 PM10 sites here in southern Doñana County, as well as Luna County. And so we also have an additional 4 sites that are PM2.5 sites. And there are a couple sites that have both. So for example, our Desert View, as well as our Anthony monitoring sites have both PM10, PM2.5. And so this is the most robust monitoring network here in the state. We do also have another PM10 monitoring site up in the northwest corner in the Four Corners area. And so our PM10 24-hour standard, it's 1987 standard, and it's 150 micrograms per cubic meter. And so to be in compliance, you need to have, you can't be in exceedance more than 1 year. So a 3-year average to not exceed more than 1. And so it needs to be 1 or less. And so there is no annual standard. And unlike the PM2.5 24-hour standard, there's a 35 microgram per cubic meter limit. And so this is also a 3-year average, but this is more so of the annual 98th percentile. So it needs to be less than 35 micrograms or less. And so like for the PM2.5 annual standard, this was just recently updated this last year. It was at 12 micrograms per cubic meter, and now it's down to 9 micrograms per cubic meter. And so this is, I guess you could say, annual weighted average over the past 3 years. And so it needs to be 9 micrograms or less. And so the reason behind that they lowered it is because epidemiological studies were showing that vulnerable populations that were affected by design values below the 9 micrograms per cubic meter as the reason behind the the evidence is supporting that more so. I guess you can say our design value here in southern Doñana County is sitting right above 8 micrograms per cubic meter. So we are in attainment of the National Ambient Air Quality Standards. And so the thing is, what is a design value? A design value is, I guess you could say, the number that's calculated to determine whether an area is, in violation of the standard or in attainment of the standard. And so, it is based on the highest reading air quality monitor for the county. And so when an area is either in attainment or not attainment, if it's above the NACs, it could be considered unclassifiable if there is no monitoring station located in the county. So air pollution is not, I guess you can say, constrained by state lines. And so this is, I guess you can say, the basis of our dust mitigation plan with other influences from surrounding jurisdictions, what we can do on our own. And so we can go ahead and go over some health effects. And so the thing is, particulate matter, it's going to be a pretty small pesky particle. And so the thing is, it's the inhalable range is less than 10 microns in aerodiameter or less. And so it is either condensable or filterable. So generally, the larger particles affect the upper airways and the thorax. So if you see this right-hand image, the areas that are shaded in red is where the fraction from PM10 to PM2.5 affect mostly. And so the fraction of PM2.5 and less affect the lower airways into the bronchioles and the alveoli, which is shaded in blue. So the main damage is caused primarily through the physical nature of the particles that cause an inflammatory response, which causes cells to die. This inflammatory response can become overworked and put undue stress on the body. So for example, mesothelioma and silicosis are 2 conditions that highlight the overworked immune response mode of action that damages the lungs from the prolonged exposure to the asbestos fibers or silico particles. Some people are at an increased risk than others, especially if they suffer from pre-existing respiratory conditions such as asthma or they are smokers. particulate matter exposure does elevate an individual's cancer risk. So there is also a correlation with individuals who are affected by particulate matter more than others who suffer from other pre-existing non-respiratory conditions such as diabetes and heart disease. So in other words, not everyone is affected to particulate matter equally, especially the elderly and pregnant women whose immune systems are weaker than the general population, and children whose body mass index relative to the volume of air being inhaled is orders of magnitude higher than adults. The effects from particulate matter exposure doesn't only come from the main physical problematic nature, but also the chemical and biological nature. Chemicals being less than 2.5 microns, which covers condensable hazardous air pollutants, since they can easily be transported throughout the body depending on the target organs, since the lungs are a very efficient means of oxygenating the blood in conjunction with the heart for distribution throughout the body. The biological nature of the involves the immune response to dust being used as a carrier for coccidioides, fungal spores that cause valley fever, with New Mexico being endemic to cocci, and a whole host of other mold and fungal spores and allergen pollens that can potentially cause severe immune responses to susceptible individuals. And so that's to us, I mean, the humans. What about the, I guess you can say, the ecological effects, or what the secondary NAC standards protect? So like, visibility impairments, so contributes to regional haze. We want to have that nice clear view of our class 1 areas particularly. And so the influences from radiative absorption, creating an albedo effect that increases snowpack melting of our watersheds earlier in the year during the spring runoff season, while decreasing plant photosynthesis and influencing cloud formation, precipitation patterns. Do you know that 60% of a cloud is made up of dust? So dust has a direct influence with the water cycle, in addition to the nitrogen cycle, through sediment transport and deposition that contributes to eutrophication of surface water bodies that are caused by algae blooms that degrade surface water quality, along with other secondary pollutants that can form, such as the influence of acid rain through dry deposition, decreasing the pH of water bodies, affecting phytoplankton populations. Do you know that fish eggs and fly larvae cannot hatch at a pH below 5, while fish kills happen at a pH of 4? The impact isn't limited to water bodies, as plants are directly affected, not through only through decreased photosynthesis, but also through nutrient utilization, which affects the overall food chain. Herbivores will have less and lower quality feed, which will have an effect on the carnivores with a dwindled and less robust population to gain the feed from. The omnivores can continue to scavenge like they always have, just with the more strained resources and a lot more hungry mouths to fend off. And so the thing is, what's the reason as far as what kind of things do we need to do once we go into non-attainment and when we violate the NACs? And so, as far as being in non-attainment, there are some, I guess you can say, increased controls that are required. We have to increase the permitting requirements. There's more emissions inventory submittals and just certain requirements, particularly for non-attainment areas. And we do have to develop a state implementation plan for these non-attainment areas. So, there's a possible adverse economic impact, with, I guess, it makes the place a little bit less attractive to prospective businesses and people that can relocate. So, the process intended for for emissions are controllable or not, and so it may not be appropriate in our situation. So, with in regards to our Anthony PM10 moderate non-attainment area, how are we going to go about trying to get some controls and be able to work with our stakeholders to protect this area. So the thing is, we do have the New Mexico exceptional events, and so every year, there's a lot, and primarily for natural events. And here in New Mexico, it's for high winds and blowing dust. That's our most frequent use of the exceptional events rule. It can include wildfires as well as tornadoes. But as far as other human-caused, fireworks and spills, that's not so much as what we're using this rule for. We're primarily using it for high wind and blowing dust, and maybe potentially in the future for wildfires for PM 2.5 and ozone if we started needing to. The thing is, for the past 8 years, Southern New Mexico averages about 10 to 11 dust events per year, with our high and low years back to back. The 2 past recent years, 2022 having the most exceedances with 16 total, and 2023 having 6 total exceedances. So it's a pretty dramatic shift from what we've experienced in the past. And so the exceptional events requirements are administrative as well as technical requirements. And so, first NMED does notify EPA that data may have been affected by an exceptional event by placing flags in the EPA's national database, the air quality system, or the EQS. So, through discussions with EPA Region 6 staff, and NMED determines if the event has regulatory significance. So, was there a violation of the standard? So, there may have been an exceedance, but it may not have, I guess you can say, been an exceedance that has kicked over into regulatory significance. So that's a pretty important piece of the step. The schedule is agreed upon, and NME develops a demonstration to submit to EPA after a 30-day formal comment period. So each demonstration must provide evidence that clear causal relation exists between the event and associated air emissions and the moderate exceedance. Now, if it's a human, I guess you could say human cause, that's well, it needs to be a human occurrence as unlikely to reoccur if it is some kind of human event. But no, in the case of natural events, I guess you can say the resulting air emissions must be reasonably controlled or preventable. And so, EPA determines if the exceptional event is not reasonable or controllable or preventable on a case-by-case basis, considering the area's past compliance history and regulatory requirements, whether if they're non-attainment, if there's any kind of SIP requirements. So for recurring events, New Mexico is required to revise the disk mitigation plan every 3 years or sooner as needed that addresses the PM an event that caused exceedances in the past. So we are past due for one. We're needing to get one in, like I guess you can say last year, but we're pretty stretched thin with our ability to be able to do that so far. So we're planning to try to get one in by the end of this year. And the thing is, what is a recurring event? It's generally 3 events in a 3-year time period that the agency has flagged in the air quality system. And the next due to similar exceptional events, the same type. So the high winds that result in high emissions of PM10. And so, we're pretty busy with just working through exceptional events. And so the thing is, what are the public health protections? Our main goal is for the protection of the most vulnerable or at-risk populations, the children, elderly, and as well as the immunocompromised. So this applies to right now, currently to Doña Ana and Luna County, with them being the ones that are required to have a dust mitigation plan. So this is all for PM10 max exceedances, and our Anthony non-attainment area is the only area in New Mexico that is in non-attainment of the PM10 standard. And so we do have a fugitive dust rule, Part 23, under our state air quality regulations. And so there is a huge education, outreach, and collaboration component to that. And so that's one of the reasons why we're having these dust symposiums, and be able to get everybody together and be able to get a good pool of stakeholders to be able to make this happen. And so we also do other types of outreach and collaboration. We do have health alerts that we send out during high PM10 event days. We do have an air quality index on our website that has near real-time monitoring results. And so we do have to revise every 3 years. Like I mentioned, we're a little bit past due for that. And so our initial submission was in 2018, September. And then we ended up revising it last in 2021 of March. So we do want to update our public notification outreach programs and some mitigation measures and just overall stakeholder engagement. In order for NMED to implement mitigating measures for blowing dust, the department must adopt a fugitive dust rule. In developing the rule, the department accepted input in the scope and source to be covered by the rule. Currently in New Mexico, Doña Ana and Luna counties are required to have fugitive dust controls in place, with the exception of the city of Albuquerque and Bernalillo County, who have their own fugitive dust rule. And so our mission, is to protect public health, the environment. This is our principles that we go by. So the thing is, this came into effect about 5 years ago, in January 1st, 2019. So there is still a lot of outreach and education that we're needing to go forward with. And again, how I mentioned, it's our objective is to protect public health, minimize human-caused emissions. There's not much we can do about the natural windblown emissions, but we can minimize our impacts. want to fulfill the exceptional events rule and our dust mitigation plan requirements to be in good standing with the Clean Air Act and the EPA, and avoid a non-attainment designation or a bump up to a more severe status from moderate for Anthony non-attainment area. And so now I'm going to go ahead and go over the scope of our rule. And so regulated sources or activities, I mean, as far as disturbed surfaces that are greater than 1 acre. So it does include construction, demolition, earth moving, open vacant land, as well as unpaved lots and traffic areas. The material storage and transport, and then roads under construction. So there are some exemptions. So for example, agriculture, if they're implementing good agricultural practices, as well as travel on unpaved and paved roads. So that's where it kind of gets a little tricky as far as like our roads under construction and travel on unpaved and paved roads. It has to be an active source of construction for it to be applicable. And so if it's a permitted operation, if they have a permit through us or, through the, like a mining permit or whatnot, then they're exempt, and as well as military activities. So in order to be compliant, this is a emission limitation type of, I guess you can say, method 22, and it is a fence line emissions. And so it entails no more than 5 minutes per 60-minute period of emissions leaving the fence line. And so there does need to be have some record keeping as far as the control measures for either the owner or operator of the site. And so they need to be applying these, and they need to be documenting, I mean, the frequency and the rate and what they're doing. And so part of their dust control plan needs to have I guess you can say best available control methods. And so we can work with at least reasonable, I mean, at the very least. And so this is a complaint-based type of enforcement. And so it is, I mean, if you complain to our hotline or online complaint, we'll actively investigate any kind of fugitive dust complaint within Doñana and Looney County. So we do have a process as far as enforcement. So we do strive for voluntary compliance, and then we start ramping it up from there as far as documenting it and start issuing out notices of violations or administrative orders of compliance. And if need be, we can go to district court and handle it through a civil process. So no, there is a lot of outreach that's still needed. So get the information out to the affected stakeholders and jurisdictions. So if anybody out there who is listening and would like for us to present to affected industry and whatnot, we're all up for those types of outreach efforts. So I'm going to go ahead and just discuss a little bit too of what Alan had discussed about the fugitive dust rules controls. And so ours are kind of broken down disturbed surfaces, as well as bulk handling, as well as storage. So our disturbed surfaces, I mean, I guess generally speaking, what we want to try to emphasize is if you can be able to engineer the hazard down, I mean, that's kind of like the best cost-effective approach, instead of trying to right away from the very beginning trying to implement very expensive controls. And so, like, for example, like simply even limiting disturbance in phases, or I mean, having certain periods where the work is being stopped can help minimize the dust emissions. Reducing vehicle speeds, using fencing as well as walls, geotextiles and dust suppressants, restricting public access, airscaping, reseeding efforts, and even potentially even using conveyor systems that, if it's like haul trucks or whatnot, I mean, to minimize vehicle traffic. And I mean, it's all kind of I guess can be very innovative, I mean, with the right engineering practices. And so for bulk handling and storage, if you have control of the amount of height that you're dropping or keeping your stockpile heights, I mean, that's a big factor in reducing process rates. It's more so for handling, not so much for storage, such as like cessation of operations, just simply stopping and using spray bars and dust suppressants. And so more so for storage, you have the windbreaks and 3-sided enclosures for your storage piles and spoils. And so Yeah, that's our fugitive dust rule. No, this is my contact information, and me and my fellow colleagues at our last event in Anthony PM10 area, where we were handing out information about dust storms and just our program in general. I was gracious enough to be able to work with our Environmental Health Bureau that day staff, and they have other program components that they were handing out to the public during that day. Does anybody have any questions or comments?
I guess, Armando, Luna County in particular has a lot of agriculture is the result of a lot of the dust emissions within that area. Do you have an idea as to how
Right.
you're going
So
to
I
be
had a
addressing
question
that?
as far as what the I guess definition of regulatory significance means. And so for example, our PM10 exceedance is if we have one exceedance each year, then that's enough for us to kick over into violating the standard as far as having, I guess you could say, an average over 3 years to not have more than one. So for example, if you're to have two in 1 year and the following 3 years you didn't have one, then those two violations would not have regulatory significance. It would only be to the point where you'd be kicked up past the standard and be in non-attainment. Another good example too is right now our PM 2.5 standard is or our design value here in Southern Doña County is above 8, and since they lowered the standard, the annual standard to 9, we would that would, once our, I guess you can say, exceedances would cause us to be above the standard, above 9 micrograms per cubic meter, then those violations or those exceedance dates, those ones would be the dates that would have regulatory significance. So right now, since we don't have, we're not above that standard, none of those exceedances currently have regulatory significance. Seems like we're running into some more technical difficulties on the online platform. I think someone was trying to say something I didn't hear, so I'm going to try to mitigate that. Okay, I'm not too sure if I'm coming through on the virtual platform. Can somebody else reassure me whether I am or not?
We can hear you.
Okay. Yeah, you know what? I wasn't hearing you guys there, and so can you repeat yourself again to sound check?
Yeah, sound check. Can you hear us, Armando? Sound check.
Yeah, so we're having a little bit, we're not getting
You can't hear
sound
us.
from the
Yeah, I can hear you.
hearing you, Bill, or Dr. Tong.
Yeah, Amanda, can you hear us?
Okay. All right, Dr. Tong, can you hear me? Can you say something? See if I.
Yeah, can you hear me? Can you hear me now? Okay, I can hear other people. Can others confirm that you can hear me too?
We can hear you fine online, but I'm
Yeah, I
not
can
sure
hear you.
in the room.
Okay, awesome.
Yeah, we ended up losing our audio somehow, but for our. So I don't know. I may need to end up just having to hold this microphone up to the thing.
Oh, that would be a torture for you. Is that a way you can change the audio, like the output of the speaker?
Yeah, I can hear you on my computer. Like I can't hear you on the speakers.
Okay, let me know how do you want to handle it.
So you're real low.
Okay. I have to change the settings, so I'm gonna quit and re-enter soon.
Oh, I think we lost you, Dr. Tong.
Okay, Amanda, can you hear me now?
Yeah.
Okay. You want me to get started, or you want me to wait for a while?
All right. Were you gonna want to share your screen, Dr. Tong?
Yeah, I can do that. Can you see my screen?
Yes.
Okay, awesome. Yeah.
Just haven't not able to get you on the microphone for some reason. Yeah, I know. All of a sudden, it's kicked off. He goes whenever we gets knocked off. So that's really good. Yeah. Last time it didn't really help. All right, Dr. Tong, go ahead and now you get started, and I might just have to put the microphone for the folks here to be able to hear.
Okay, sorry for that, Amanda. I will try to speak loud. So for those online, probably you have to reduce your volume a little bit. So thank you very much for this opportunity to present here. I'm Daniel Tong from George Mason University. Always my favorite workshop come to present our research on dust. And this year, I'm going to talk about what is inside a dust particle. That's benefited from the 30 years observation from the improved lab work. So I'm going to focus on the dust chemical composition, not on the trend today.
Yeah, we're running into little difficulties.
Okay.
All right.
You good now?
Yeah.
I think in many climate and Earth system models, dust is treated as a single component of aerosols, such as this one is the NASA geosphere model. You see the red, which is dust, it's been spread around the globe just as a single aerosol component. So the question is dust really a single chemical component, or can we treat it in that way? So that's the motivation for us to start with dust, chemical composition research. To be able to study this problem, we have to first understand what is dust. It sounds like a very naive question for this group because you are all experts on dust. But really, there's a lot of confusion in the public and also among the scientists about what is dust. So I took the Oxford American Dictionary, it happened to be on my bookshelf, to look for dust. Its definition is fine particles of earth and other matters. Actually, they give a lot of examples. Looks like we have at least two major group of users. One is people studying the atmosphere, and the dust can be referred to wind-blown dust, anthropogenic fuel dust, we all call it dust, and some people also call volcanic ash as dust, and some people use dust for the general sense of air pollution. In the other group is so-called house dust, dust in the built environment, that including skin cells and shared from our bodies, pollen and human hairs, animal furs, fibers from textile and papers, minerals from outside, and many, many other things. So this is actually two group of use of dust. For the scientists, we are trying to focus on the scientific definition of it. For example, the World Health Organization, they define dust as the solid particle ranging in size, which is very important. Size of particle is very important. Below 1 micron up to at least 100 micrometer. I believe there's a typo here. It's not a 1 micron. It should be 1 millimeter, which may be or become airborne, depends on their orange. The physical characteristics and ambient conditions, that's the definition. So here we just simply took one from our earlier paper, that's referred to airborne soil particles. So we define dust here. So why do we care about the chemical composition of dust? Dust can come from many different backgrounds, and their parent soil are very different. They give you a very different chemical composition, because you can imagine for the emitted dust. And also dust can go through chemical reaction after emission. So this is a process called a chemical coating. The coating can add a lot of anthropogenic pollutants to dust. Dust is basically like a vehicle. The other way is after transport, the dust size distribution will change, where it's not clear that different particle size will have different chemical composition. So this is another question we want to address here. So because of these changes, dust can have different ways to impact the human health, such as crustal elements may have different health impact with heavy metal. Even EPA right now use PM 2.5 or PM 10 total mass for assessing health impact of aerosols, but people are also moving towards component specific health impact. And also we care about microbes in the dust, such as cocci fungus that we are familiar with. It can change the climate radiation, also impact the ecosystem, and also atmospheric chemistry. So there's many ways we have to worry about chemical composition of dust. So how do we monitor dust? We're using the IMPROVE network, which is the interagency monitoring of protected visual environments that's operated by states, and local government, and with funding from EPA, and also support from National Park Service. So they have very nice measurements, long-term measurements for past 30 years, measure both PM10, PM2.5, and also PM2.5 chemical composition. That's really give us a very rich pool of information you can use to study the chemical composition of dust storms. So the first thing we want to do is separate dust from other particles. We started with a satellite-trained dust identification method. You look at the live satellite images of dust storms, as was shown many times in this workshop, and then you find a collocated ground measurements, and you look at the trend of different chemical components before, during, and after dust storms. Here we find that the PM10 or PM2.5 concentration all increased during dust storm, which is something everybody knows. And then we also can see that the crustal elements, such as silicon, calcium, potassium, iron, they all increase at the same time because they are the major components of dust particle. But not everything will increase during dust storm. So one thing will decrease during dust storm, which is a very important feature of dust particle is the PM2.5 to PM10 ratio. So PM2.5 is the fine particle, PM10 is the coarse particle, and the fine particle. The ratio represents the age of the plume. If it's very young, the ratio will be very low. If the dust plume is very old, the large particle will settle faster, and then the ratio will increase. So you will see a decrease of the ratio, and that's a very important indicator. So if you have a concurrent measurement of PM2.5 and PM10, you actually can have a very powerful sample and powerful method to identify dust. So we identify dust with 5 indicators, that including PM10 and PM2.5 high concentration, the low ratio with a high crustal fraction, crustal elements as be rich in dust, and no anthropogenic fraction, that including copper, lead, and zinc, and also no enrichment factor. Enrichment factor basically tell you how different is this particle from Earth's crust. If it's equal, it's similar, which means it's completely from dust. If it's from the soil, if it's much higher than the crust, which means something has added to it, so it's called enrichment factor. So with this method, we were able to detect the dust. However, right now we have a lot of discussion about what is a dust storm and how it's related. Actually, dust storm is a weather phenomenon, right? Defined by visibility. And IMPROVE does not provide that information we need. Right now, it's does not have direct measurement of visibility, for example. So in order to derive the relationship between visibility and PM10 concentration, and you have to look at the Beer-Lambert law here. Get my pen to work. The Beer-Lambert law tell you that the contrast from a background will decrease exponentially with distance. So this is the law here. And the lowest visual perceptible brightness contrast, which is like the farthest you can see, is about 0.2 to 2%. Then you can add it here, come up with this equation. Basically, this is the aerosol extinction coefficient, and this is the visibility length. However, we do not have the direct measurement of that. So IMPROVE used this formula by Michael Pitchford, developed in 2007. You have this formula, and you can see that different chemical composition give you the different extinction coefficient, right? So I did a rough estimate. I found that you actually require instantaneous PM10 concentration to 400 and to 2000 microgram per cubic meter in order to reach the 1 kilometer visibility. That said, it's almost impossible for us to derive this to get the instantaneous visibility from IMPROVE for several reasons. First, the samplers was designed in a way, at least before 2024, and right now they have changed the algorithm. So during the dust and wildfire events, those samplers will be clogged, right? So they will have no enough time. In the past, we just threw away that data and consider that's invalid. Right now, we count it, which is good. But because of that, you will not to be able to measure that high level of concentration even if you had one. Second is this sampling period is 24 hours, so we do not have enough information to get the hourly or even sub-hourly concentration. So as a trade-off, we adapt a sort of intermediate standard. We use the dust storm if it's a PM10 concentration is higher than 40 microgram per cubic meter. Remember, this is a 24-hour average because the background concentration is way below 40. So this can give you concentration that's hourly concentration because most American dust here are short-lived, right? So it can give you this instantaneous or hourly concentration close to 400 or even above. And we consider that the concentration beneath that will be a mild dust storm. It's kind of arbitrary, but it's the best we can do for now. We also apply additional criterion, such as the ratio have less than 0.35, and the soil to PM10 ratio has been larger than 55%. So using this method, we came up about 1,200 severe dust storms from 1988 to 2022. So what did we learn from this rich data set? We first look at the major dust components, or I divide it into different states. The number one state we have actually is Arizona. It's not surprising because they have the most frequent dust storms in the state. Even satellite is having a lot of trouble to see any dust storm there. So very rarely we see satellite images we see over New Mexico and Arizona. That's because they have a lot of haboos and the cloud just masked everything out. So this rich ground measurement is really a treasure, a national treasure here. We found that not surprisingly, fine soil is the number one component. I will talk about a little bit more about fine soil definition in IMPROVE. And Colorado has the highest one, almost 3/4 of the dust is made of fine soil, and others is between around 60 and 65. The second largest one is organic matter. That's actually give us a lot of thoughts about what kind of bacterial fungus they can bring to the city, right? So that's actually have 12, almost 13% of the dust particles made of organic matters. And then the next one is sulfates, and a little bit of nitrate and other things, right? So if you look at the regional differences, we find Oklahoma has the highest organic matter and also the highest sulfate. I'm still trying to understand what causing the regional differences. So I will be very happy to hear any suggestions. What do you think are causing this spatial variations? And nitrate in California is the highest one. It's probably not surprising because they have a lot of fertilizer application. In Washington, they have very high level of chloride. This is another puzzle for me. What is it's like 8, 9 times higher than the national average. So move on, talk about the fine soil. Fine soil is calculated using this formula developed by Jenny Han. She, you can find it in the IMPROVE User's Guide. So we look at these 5 crustal elements. We found that silicon is the highest one. Second is aluminum, and calcium is the third abundant one, but calcium has the largest spatial variation. For Washington, remember, Washington State, and they have the lowest one, and Nevada has the highest one. Trace metals, we do not see a big difference compared to the major components, but there are some spatial variations. For example, Arizona has the highest copper concentration, which is about 10 times richer than the next state, Nevada. So this, you can play with this. The question that we asked earlier is, does the composition change does the plume age? Does the particle transport further away from the source? Do we see the chemical composition change? So we use the PM2.5 to PM10 ratio as a proxy for the dust plume age. And we found that for aluminum, for example, here, the abundance actually increase with the larger ratio, which means that the aluminum mostly sit in the smaller particles. That means the coarse particles, they will settle first. And so actually smaller particles have a higher abundance of aluminum. But this one does not occur for other elements. So for most other elements, and you have flat, or they don't have a clear pattern. You can also look at this, because this can only show in the main components, but you can look at it, all the components at a log-normal scale. You can see all the components. It almost gives us the same conclusion, that the chemical composition of dust remains stable with plume aging. So to summarize my this research piece, by the way, this is still preliminary result. So we have the 30-year dust composition data sets right now developed from IMPROVE. We're showing the spatial variation in dust composition, especially among the main components of that. The other thing I did not get time to show, but I'm working on that right now, is to see how the dust is different from the Earth's upper crust. And we actually found that the dust has a lot of more neutron and halogen elements right now compared to the crust, to the upper crust. So and finally, the composition stays relatively stable during the near source transport. So I also want to take this opportunity to talk a little bit about other community dust activity that may be of interest to this group. One thing is the United Nations have the World Meteorological Organization. I think they are very, very interested in this group's work, such as the New Mexico DOT's dust mitigation. And it's amazing to hear that we don't have major fatal crashes. So this group actually is coordinating global dust forecasting and assessment. I'm serving as the global chair right now for the coming 2 years. It's a global network of sand and dust storms research and forecasting centers. It's trying to bring people together to do dust research, assessment of dust impact, and also promote use of available dust products and also mitigation methods. So I think I'm going to follow up with some of you on the research that you are doing, and maybe we can see if that's a way we can help you spotlight your work in the international stage. We just had we meet once a year. That's mostly we talk about the UN dust activities. They publish the Airborne Dust Bulletin. So this is also a good opportunity for you to expose your work to the international community. And we have help the UN to develop a global dust science implementation plan, and also they help with the capacity building. So a lot of things they're looking for example, dust mitigation, they actually want to learn about your successful stories and see if other regions, other countries can copy that. So there are a few new initiatives I want to bring up. One is they are trying to bring more operational dust forecasting to regions. They are developing ensemble dust reanalysis for the past 20 years and trying to map global dust vulnerability to see who and which communities are most impacted. And they are developing a dust product for all the major health assessment, such as the Lancet Countdown. And also they have about 5 or 10, I think 9 or 10 papers right now they are going to propose, and there will be abundant opportunity for people to work together on both research and implementation and assessment. So this is the dust reanalysis ensemble. I'm going to skip here because no matter what time, dust bulletin, when they publish all kinds of stuff. You can take a look at WMO Airborne Dust Bulletin. If you have anything you'd like to contribute, you can email Andrea Sini. She's right now is the chief editor of this bulletin. And we'll drop her email in the chat later. And another important thing is last year, we finally got July 12th designated as an International Day of Combating Sand and Dust Storms. So because it was announced last minute, we did not get much time to celebrate. And this year, WMO and Dana are trying to come up with a celebration, a more decent celebration. So we definitely welcome you to participate and also attend this event. I don't know. Corinne is going to have more to say about this. I will stop here. Thank you very much for your attention.
Thank you, Dr. Tong. That was very interesting work that you have presented for us today. And so does anybody have any questions or comments for Dr. Tong? Very well, thank you. Thank you for presenting today for us for our dust symposium.
Yeah, thank you.
And so with our next presenter, we have Karin Arden Dreyer. She's from Texas Tech University, and she's going to be presenting Dust Under the Radar, rethinking how to evaluate the impact of dust events on air quality in the United States.
All right, can you hear me?
Yes, I can hear you loud and clear.
Can you see the slides? Armando, can you see the slides?
Yes.
Yes.
Perfect. All right. Well, thank you so much for having me today. I'm sorry that I can't be there in person, but I'm really looking forward to meet you all in person in our next time, whether we're going to have a chance to talk about dust. So today I'm talking about a paper that I have with my collaborator, Catherine Clifford and Jenny Hand. I believe Jenny is here on a call. This was published in GeoHealth in early December, if I'm not mistaken. And it's more of a concept to bring the thought that dust is important, but we are underestimating it. And we're not evaluating the true impact that it has on air quality. And therefore, we can really understand the impact fully, the impact that it has on health. So I know talking to everyone here, why dust is important is trivial. That's why we're here, because we all care about dust, because we all see it as something important. But a focus of today will really be on air quality and mainly on people health. In our paper, we bring up several issues that we see in the dust community. And we heard some of it already in our earlier talk. So there are three factors that result in underestimating the social, environmental, and the impact that dust event have. And it's making them receive less attention because they don't seem to be important. So we're going to talk about some of them. And I'm going to mention just 3 out of the variety that we're going to cover. So spare monitoring station with irregular spatial distribution in dust influence region, inconsistency with dust sampling method and sampling frequency and scheduling that can lead to miss of dust event and therefore underestimating of the dust particle concentration. So digging in, we heard some aspect in a previous talk, which is the fact that we like to call it dust storm all the time. And it doesn't matter the condition that it appear, but the World Meteorological Organization have specific definition. And if we call the child by his name, it might be easier when we want to reach out to the community and try to show that there's differences. So how do we define a dust event versus a dust storm? A dust event in general is when we have a reduction of visibility below 10 kilometers. But a dust storm will be a more extreme event. Obviously, we'll have more particle that will block the visibility. And in that case, they will reduce the visibility below 1 kilometer. So there's lack of consistency in how we define them. We call it all dust storm. Also, we can see in the media sometime that there's a usage of sandstorm versus dust storm. Now, again, these are 2 different meteorological phenomena where sandstorm are refined to sand particle. They are larger particle, can uplift to higher altitude, and they would hit your leg if you walk on the beach and you will feel them. But the dust that may come as the sandstorm process and involve, they can go up to a higher altitude and they can move to a further distance. And obviously they will have a bigger impact. Another issue that we have been seeing, and I was kind of happy to hear Armando talk to know that at least in New Mexico, they do put under and define some of the dust event as exceptional. But we know that in many states around the US, dust is often dismissed in a policy and in management decision. And a lot of the time, they would just define the event as exceptional. And they might be able to remove it from the database because it's considered as a natural event that regulatory can use it. And we've seen it in some of the state, and Catherine Clifford has several papers in the topic, and you're more than welcome to look for them. Now, let's start talking about the aspect of air quality. How do we monitor the impact of dust on air quality? We have different type of monitoring system across the US, and we heard some of the regulatory aspect earlier today. In 2020, we had more than 1,000 sensors across the US. We have PM 2.5 sensor, and these are the red dot that you see here. We have PM 10 sensor, and by the way, these are just different sizes of particle. PM 2.5 particle can get deep into our lung. PM 10 will get into the upper respiratory. So these 2 definitions are defined for health purposes. We also have in yellow some sensor that there's both sensor at the same time in the same location, PM10 and PM 2.5. And we have the improved and CSN network that can give us a lot of information on PM 2.5 chemistry, on PM10, but they're measuring in a daily average. So only 1 data point per day. And we'll talk about the time that they're measuring. Now, to look at the impact on air quality, we normally define what is the daily concentration, to how much concentration we were exposed in the 24 hours. And you can see here at the bottom of the figure, there are the World Health Organization threshold and our EPA threshold, which is the American Environmental Protection Agency. And they're different. Now, obviously, the World Health Organization is large. It includes many states, but they also updated the regulation about 3 years ago, and they lowered the threshold because new epidemiological studies are showing that exposure to even such a low concentration can cause some problem. So what is the problem? We have some sensor, right? But the problem is that a lot of places that are impacted by dust does not have any sensor. So we could have a case where we would have a dust that would pass by, as you can see here in the images and in the video retrieving from Aerosol Watch, which is GEOS, that there's basically gaps, there's spatial gaps in area that does not have any sensor. So I like to laugh and say that no sensor, no dust. If we didn't detect it, it didn't happen. It's very important to have those sensor because we can see the data from the satellite. We know something happened, but from the satellite, we can really get the concentration that people here at the ground were exposed to. So there is spatial gap that limit our knowledge on how dust impact on air quality. Let's talk about other aspect. We mentioned earlier that we can look at location where we have PM 2.5 and PM 10, and I was very happy to see that Daniel showed some of this implication where we can define either the ratio between them, between PM 2.5 divided by PM 10, and we're looking at lower ratio to define a dust event, or we're looking at coarse particles. How many particles were in between the 10 to PM 2.5? So we can get that information, but the problem is, first, there's not that many sensors with both of these PM10 and PM2.5 sensors. And again, there are large area impacted by dust that doesn't have these sensors. Also, we found that it really depends on the source. Sometimes both concentration will increase, both PM2.5 and PM10. So this coarse particle might be smaller than we would expect. And in other cases, the difference might be enormous. So we have much larger particle in this case compared to here. So we might need to do first have more sensors. And the second thing is to try to identify those locations and the sources of the particle. Another problem is the fact that while we have all these sensors, we don't have any measurement for PM 2.1, which are respiratory, can go into the bloodstream. We don't have any measurement for PM4. We don't have any measurement for total suspended particles, and we really don't know much about the sign distribution. Now, the sign distribution of the particle basically tell us the concentration as a function of size, and we know how many particles we have of different sizes. This is crucial when we want to look into the impact that they might have on health. But even if we're using similar measurement, with different tweak, we can get different conclusion. And this is something we're showing in the paper. So here we have some measurement that Jenny produced in one of the reports for Improve, using improved data and using fine dust annual values and also information on the coarse mass. These are two different calculations using the same instrument. And we can see that there's some spatial and seasonal variability in this reconstructed fine dust and coarse mass. And this is basically a knowledge of the dust side distribution and the coarse mass composition that is crucial for us to understand how these events are changing and how the spatial and temporal impact of these dust would be. So even using the same method, a different tweak of how we look at the data, we can get a different conclusion. We can come up to a different conclusion. Another thing, although the Improve and the CSN are wonderful tools that allow us to look in the chemistry, and we just heard a great talk from Daniel about it, and this is definitely information we don't have. One of the problem is that they collect sample only every 3 days. But the dust doesn't care when the sampling happened. Dust can happen and we might be lucky, like we have here, to collect it, to get the sample in our filter for the analysis. But dust can also happen in between those 3 days when we're not sampling. Also, another thing is Improve provide chemical specification for PM 2.5 only, but not for PM10. And without these additional information, we can only speculate regarding the source and transport of this dust. So it's again information that we don't have. So if we already have a sensor in a location and we're able to capture the PM concentration, I love to show this video from Texas because it really shows a big haboob, a big convective event we had here in 2011. And just to show you how many particles were in the air, just by visualizing this blackness that happened. But when we look at the PM concentration during that day, we can see that there is an increase as we expected. But as I mentioned earlier, most of the regulation are used daily values. So the daily concentration in here was 23.5, which was below the EPA concentration. Up until a few years ago, it was also below the World Health Organization. So if we're only looking at daily average, we would miss this day completely. A lot of the time, the regulation that were developed, that we're using the threshold, are based on anthropogenic pollution and not based on dust. So looking just at this day, those images, I hope made you understand what happened here during this day. You would not want to be outside when this haboob passed by, but looking at the daily average would miss this event completely. So average across the day mask the fluctuation of the concentration of the dust particle. And this is not unique for Lubbock. We've been analyzing these short convective events for many locations, and you can see it for Amarillo, you can see it in Lubbock in multiple events, we see it in the red dot, this very sharp increase and decrease in PM 2.5 concentration, and we have the wind gust and wind speed in the different shades of gray. And this is happening. And a lot of the time, we would be below the daily concentration, and we would just miss them completely. And just to show you, these are data for 20 years. All these big spike, black spike, are hourly concentration of PM 2.5. We have a lot of them. We have quite a big number of them. So if we only looking at the daily average, we would not know that they exist. So it's one of the reasons when I moved to Lubbock, I decided that we need more information, because here in Lubbock, we only have one PM 2.5 sensor. We don't have other sizes. So that's why I designed AROS, which is Aerosol Research Observation Station. And recently we made some adaptation to the sensor. This is how Lubbock look like. This is where we have our station. This is the meteorological station that we have here in town in the airport, and the only PM 2.5 sensor available we have in town. So currently, since March 2024, we have a low-cost sensor, high-volume sampler, the same instrumentation. Mainly we're using the GRIM 11D and the OPS for PM 2.5, PM1, PM4, and PM10, and also for side distribution. And we also received recently, as part of an EPA project, a reference monitor that will look into the PM 2.5, and this is the EDS 180. So just to show you a glimpse of some of the things we can do, we have here two dust events, one synoptic, and you can see this flow of dust, how the wind increase and the visibility decrease, and I'll show you the concentration in a second, and a convective dust event, which you're going to see this haboob pass by. And for those with sharp eyes, you might be able to see this wall of dust here in the radar, sharp decrease in visibility, sharp increase in wind speed. When we look at the daily average, one thing I didn't mention is the fact that we can look at every minute using our instrumentation, not just 1 hour, which is the standard. We can also make different calculation every 5 minutes, every 10 minutes. So when we're comparing these two events, we see that the synoptic dust events seem to be much higher concentration compared to the convective. And the duration that they lasted was different, 12 hours in the synoptic compared to 20 hours. You can see here how they are compared to the threshold, but just look at the standard deviation. And this is basically the impact and what I want to show you. A lot of the time we don't look at the standard deviation, but we can see something happen during these days. So we might not see these days as a crucial day to look into their impact and what happened outside in the air. Another important aspect is a lot of the time, because we're measuring, that's the standard, every hour, we report every hour with our gravimetric measurement, we can miss the impact of these events, and especially these short events. Most of the dust that we have here in the US lasts less than an hour. Our extreme event will last longer, but majority of the dust, especially for West Texas, and we also examined it for Arizona, less than an hour. And if we're looking at the hourly concentration of these two events, and these are the different PM sizes, we would define the synoptic as a much stronger event, had much impact concentration. But if you start to look at the narrow time frame, this convective lasted for only 20 minutes. So if I'm averaging every 10 minutes, we can see this big impact. Very short duration event, much higher concentration compared to the synoptic. This is not unique only for West Texas. This is something we have been seeing also in Arizona. These are measurements that we retrieve from the Maricopa County, Air Quality County, and we're currently working on a manuscript that highlight this impact. If we're looking at the PM concentration as an hourly concentration, we are missing the true impact of this concentration. This is just example of one event with the different daily average, but I want to highlight the next figure because we can see here a more in-depth observation on one specific event from July 2022. These are the wind rows representing just the time when the wind was above 6 meters per second. And you can see that not all PM sensor will be impacted in a similar way, because it really depends where the dust come from. So we can see that the dust came from this area, and only these two PM10 sensor were impacted the most. Now, again, if I'm looking at the hourly concentration, I would see, oh, there were a lot of particles, but actually the true impact were much higher. The concentration every 10 minutes was almost 2 times higher than the one every hour. So if you're outside during those 10 minutes, you would have been exposed to much higher concentration than what we would think regulatory. So we might need to start rethinking how we're looking at the impact of dust, especially here in the US. In the Mediterranean, dust lasts for hours. Concentration remain large because we have such a high sources. Here in the US, our sources are located in different places, but they're impacting the local community in a different way. And we should look at these impacts, and we should start thinking about the impact that these dust events might have. Now, another aspect that I always love to highlight is the fact that people think that dust only contain large particle. And if they're large particle, they're not problematic for the health. So let me show you. Remember those 2 examples that I showed you for those 2 dust in Lubbock? So we have here the time before the dust and at the peak of the dust for the synoptic and the convective. This is 1 micron. 1 micron can go straight into our bloodstream. There are high concentration in dust event of small particles. So we should stop thinking that they're not problematic. Just to show you and highlight some of these impact, in our station, we have the high volume sampler. So my student, Sandra Ramirez, have been conducting experiment with cells. And we see here 2 different days, dusty days, where we see the PM concentration increased. And we also see a high concentration of larger particles. And here, in this example, the clean day or the non-dusty days had higher concentration of small particle, but keep in mind, this is the 1 micron. So we still had some high concentration of these dust particles. Now we take those samples, we extract them from our filter, and then we expose them to human lung cells. And we look at the health impact that these cells will have. So again, these are our different maps and the filters for the non-dusty and the dusty days. And we have here different time steps because we're exposing the cell for 72 hours, but we can take a visualization at every 15 minutes actually. So summarizing the impact, we can see that we have the dusty day in orange and the light brown, the non-dusty days. We can see that not many cells died in the first 24 hours. And in this specific event, we probably, if we were exposed outside, we would not get an asthma attack. But 48 hours later and 72 hours later, we can see how many cells starts to die more in the dust compared to the non-dust. So when we start to see cell death, that means there is an impact in our lungs, and that can turn into, in some cases, inflammation. We will feel it as an asthma attack or COPD. And this is something we're trying to look at. We would like to look also on the chemical composition of these particles, of these samples, to see, linking back to what we saw in Daniel talk, if there's specific chemicals that could contribute for this higher death rate. So overall, moving forward, what we need, first of all, awareness. Be awareness, use the right term. Obviously, there is a need for consistent with more frequent measurement, especially in dust influence location. We need different type of measurement. We need measurement of particle distribution. We need measurement of composition. Without them, we're not going to understand really how dust in place X impact on people in a community health compared to other places. Ideally, we could have had low-cost sensor, but unfortunately, the current low-cost sensor are not really good for dust. So really hoping that at some places or in some time point, we will be able to develop low-cost sensor that will be good. And then if we can create a network dedicated for dust and low-cost sensor in urban places, that would be great. So summarizing, if you're not familiar with Dana, please join us. We are Dust Alliance for North America. I think Daniel mentioned it earlier. We are an organization for people who love dust, like dust, want to talk about dust, think the dust is important, we have a monthly webinar, which I'll show you in a second, our next coming up. We also have a call for paper, and our deadline is May 31st. So if you have something that you think will fit either GeoHealth, JGR Atmosphere, or Earth Future, please consider submitting. Scan to join our webinar. All our webinar, except those who are requested by the presenter not to be recorded, and they are available on our website. And next Friday, we're going to hear from Luis Ladino from UNAM in Mexico about the impact of dust reaching the peninsula and how it impacts on air quality and cloud formation. So with that, I would like to thank you for your attention, and I'll be happy to take questions if there are any. Thank you.
Thank you, Karin. Very interesting presentation. Does anybody have any questions or comments for Karin?
I have a question for you, Karin. So in the most dust-prone area, we do not have dust monitors. I know it's very nice you have set up one, but should this be a coordinated effort by the region or the country? What do you think would be the best way to pass forward?
Oh, sorry, I realized I'm muted. Absolutely. If we could have more sensors, that would be great. We would be able to get more information. We would be able to understand how the PM concentration. One thing we've been seeing for Arizona, especially in the Phoenix area where there's a lot of sensor, is the dust is very spatial. It might impact one neighborhood, but not the other. And we will not be able to see it. I mean, thankfully, we'll have satellite that can show that aspect, but we won't get to know what's happening at the ground and what people are exposing to at the ground level. Yes, ideally, more sensor, the better, but we know it's expensive. And it's probably going to be hard to convince the government to put more sensors. So maybe moving into low-cost sensor that they're cheaper will be better, but don't use the low-cost sensor available nowadays to measure dust because they're not good for it.
Thank you.
There's another question. And so on the chat, there's a question that it's asked, can you expand a bit more on the current status accuracy of low-cost sensors for PM10 and PM2.5?
Is the question for dust or in general? Martin, just so I'll understand the question. I don't know if you're typing. All right, I guess I can talk.
Let me stick. Yep, it's
Go
for
ahead, go
dust.
ahead.
I think I'm particularly interested in PM10 and PM2.5.
Okay, for dust purposes or general, like anthropogenic pollution?
Comparison with FRMs and more regulatory monitors for use in our networks.
So if you are so first of all, if you have a low-cost sensor, you want to be sure you co-locate it with the reference monitor and do some calibration so then you can correct the concentration, because the low-cost sensor are not accurate. Some sensor overestimate, some sensor underestimate. Most of the studies are showing that for PM2.5, you can correct the sensor and have a close accuracy for the reference monitor. But I can tell you that for dust, that's not the case. PM10 is horrible. And there are new studies coming up to show that the PM10 is problematic because the fan used in those low-cost sensor is not strong enough to suck the large particles into them. We have 42 low-cost sensor now in our station, and we did have a dust event several weeks ago. The comparison is not good. Not good at all. So be careful when you look at dust. For anthropogenic pollution, if you do the correction, it will be okay for PM2.5, not so great for PM10.
Great, thank you. Yeah, that's helpful.
We have a question from the audience here, Karin.
Great. Thanks for your presentation. You had mentioned
Sorry, can you get close to the screen? Thank you.
okay. Yeah. So you had mentioned the readings that I guess one of the monitors in Lubbock had shown more toxic compounds on high dust days versus low dust days. Do you have more information on those specific compounds?
No, not yet. We're hoping we have enough particles on the filters and we're hoping to run them in an EDM, SAM EDX, sorry, to look what are the chemical composition on these days to see if there's differences, but we have not done that yet.
Okay, thank you.
Of course.
Are there any other questions for Karin? I do have one comment, and so I just wanted to bring up the I mean, it's the exceptional events, and you probably had a curious your smile about just you know, the data being excluded and not removed.
And thank you for mentioning those things. I was so happy to hear that in your talk. And I think, you know, you're really finally showing that some states are really putting an effort into that. But unfortunately, in states, especially up north, we don't get to see that. But sorry, go ahead.
Oh, no, I was just going to say that it's just, I mean, if anything, a little more scrutinized because of the whole public comment period and having to get concurrence through EPA and just that whole process just really kind of just shines a light on all that data, more so than all the other just background data. So with that, I mean, do appreciate you presenting today, and that was some very interesting information you provided to us. Thank you.
Thank you for having me, and thank you for a wonderful workshop, as always.
Thank you. All right, and so I think this is where we are able to give our farewells, and so I'm just gonna kind of just this is we ran into a little bit of technical difficulties here. We're able to make our way through as far as I mean, running into the audio issues with I mean, our venue here, and as well as I mean, we did run into a little I guess issue with our power. So just I mean, do appreciate your patience today and with us being able to get the in-person event off the ground. We started off with 6 people here. We ended up with 3, and so I mean, I think we're doing pretty good for a beginning event to be able to get I mean, ourselves in gear to be able to have more in-person events. I know we were kind of making do with what we're with our constrained resources, and so no, we're getting. I think we were able to toe the line pretty well, I mean, through all these virtual symposiums, and so you know, with I mean, I guess you can say with the blessing of the venue, if they're still willing to give us the opportunity to have in-person events, I look forward to our future event. And so you know, with the I guess you can say with the wrap as far as I mean, with our symposium today, you know, we've had a good full morning of presentations revolving around research and mitigation with our Lordsburg Playa efforts with the New Mexico Department of Transportation and NMSU with their work that they're doing over there. So I do appreciate them coming today to be able to present that information, as well as our partners from Albuquerque, City of Albuquerque, and so able to present their dust mitigation plan and fugitive dust plan requirements with us today. And you know, do appreciate you know the folks from George Mason University as well as from Texas Tech. I mean, you guys are always a very engaged stakeholder, and we do welcome you guys here in the future to keep the subject of dust and keep us all as like-minded folks who you know enjoy this work and know like and know the importance of the pollutant of dust and how it's easily just kind of swept under the rug per se. You know what I mean? But I mean, with us on our work that we're doing, it's we're breaking some grounds here, and especially over there at the Lordsburg Playa with the amount of remediation efforts that are being done over there. And so I would love to bring this type of work to more so to another a bigger audience, and with our joint advisory committee that we work with our partner agencies and the Chihuahua partners as well as our Texas partners. We'd like to get like to propose some of those projects to. Some of those areas are really in need of it, because if you look at our you can see our satellite imagery whenever we're getting some of these real strong southwest flows, those playas down in the Mexico region are letting a lot of emissions, and so I think those areas would really benefit from this type of remediation work, and other areas around the country that we are able to identify and be able to provide the necessary resources for those areas, and be able to I guess you could say give ourselves make that the hardest punch. With each dollar that we're able to and our knowledge combined to be able to also strengthen and our dust mitigation plan, but also not just the mitigation plan, but all of our other efforts individually. And so it's a matter of coming together for these events. And I would love to continue here, definitely in the spring. But if resources allow, would like for us to maybe have one here in the fall, if we can, at least a virtual, if anything. But just stay tuned. If everything works out as so, then we'll continue to have these in the fall and spring. But definitely, we'll be back here in the spring to be able to provide something. And so, with that said, I do appreciate everyone coming today, especially the folks who came in person. You guys made it all worthwhile for us to be able to have an in-person event, and I do apologize for whatever kind of technical difficulties that we had, and I think we were able to work through them pretty reasonably and be able to still provide a decent symposium for everyone. And so, with that said, I'll look forward to reaching out and working with everyone. And if you have any questions along the way, feel free to contact me. Or if you have any concerns on how to strengthen our dust mitigation plan, I'm all open for suggestions, or even our symposiums. So I'll go ahead and wish you guys a nice rest of the day, and have a good day, and I'll see you guys for next symposium. Thank you. Thank you, Dr. Tom. Appreciate it. You guys take care. Thank you, Karim. Dr. Hutchinson. Take care. Bye.